Hey guys, and welcome to a brand new tutorial series. So in this series, I'm going to be teaching you Java from the beginning. So starting at the absolute basics, setting up an environment, how to create variables, methods, like all that stuff, and then moving all the way up into the advanced stuff. This is a beginner tutorial series, so I'm going to treat this as if you have never learned any programming language before. Okay, so let's go ahead and get started. And the first thing we're going to need to do is download a IDE, and this is where we're going to be writing our Java code, okay? So it's called Eclipse. This is what I'm going to use. Use whatever you want, but if you're a beginner, I recommend you just follow along with this because some of the things I'm going to do are specific to Eclipse. So go to this link, it's in the description down below, and just click on download, and then obviously 32 or 64-bit. I recommend 64-bit as most of you probably have a 64-bit machine. Once you download this, if we go, sorry, I've already got it open here, but if we go to our downloads, we will see that it should give us something like this. Double click on it, wait for this to boot up, might take a second. Okay, it's going, let's see. And once we're in here, we're simply going to select Eclipse IDE for Java developers. We don't need to be using any of this other stuff, just this one right here. Okay, so we're going to install this. I already have it installed, so I'm not going to do that. Now it is going to ask you for a project directory, something like that. So if it asks you for that, just choose wherever on your computer, it doesn't really matter. Okay, so once you've had that installed, you chose your project directory. Now we're going to be in Eclipse. Now to start a new project, what we need to do, so it should look something like this, by the way. You're going to click on File, New, and then Java Project. Now here I'm just going to name mine Tutorial, and then let's see here, you can just leave all the rest of this stuff blank. If you want to change the location, go ahead, all right? Click Finish, and there we are. So once we have this, it's going to pop up in our left bar, the Package Explorer. I'm just going to shrink this a little bit. And what we're going to do is we're going to go down to Source, or, oh, I already have a package name tutorial. One second. I'm just going to create a new one really quickly and then walk you through this so it's fresh. Tutorial 1. Okay, finish. All right, we get tutorial 1 and we get source, okay? Now inside of the source, what we're going to do is we're going to right click on this. We're going to click new and we're going to click on package. Now, I recommend you just leave this package name the same as your project. So I'm going to do that and click finish. And then inside of your package name, I'm going to click new and class. Okay, so once I click class, it's going to pop up here. It's going to allow you to select the package and the source folder, just leave those blank. And the name, you can name this whatever you want. In my case, I'm going to name it main, okay? Type name is discouraged. Okay, so let's name it main with a capital M, all right? Just because Java likes that. And then what we're going to do is make sure you check on this public static void main. We need to check mark this because we're going to need this function created so that we can start, all right? Inherited abstract methods, you can uncheck that. Actually, we'll check that. It doesn't really matter for right now. Okay, so now we're in and we've got a little bit of code going here, and I'm going to explain what this is, and then we'll get into just coding like a really basic thing, just printing a few things to the screen before we move into the next tutorial where we talk about data types. So Java is an object-oriented program language, meaning that everything happens inside of something called classes, and everything is known as like objects, all right? Now, you're not going to understand very much of this right now if you're a beginner, but for some of you guys that are more advanced, you should kind of understand what this means. So classes are these, okay? And everything in Java is written in a class or an interface or something else, but in our purpose, just think everything is written in a class right now, okay? Now, inside of this class, we have a special method is what it's called. And these methods are what I'm highlighting right now inside of these curly brackets, public static void main, okay? You don't have to know what those words mean. Just know this method is important, and this is what we're going to be writing all of our Java code in for right now. So if you try to write code outside of these little curly braces, not inside of this method, that's what we're calling it right now, okay? Your code is not going to execute properly unless you know what you're doing, which in our case, we don't yet. So all the code we're writing goes inside of this public static void main inside of these curly braces, all right? Now the first thing I'm going to get us to do is just print something to the screen. So to print something in Java, we're going to type system.out. My computer's lagging, one second, .println. And this simply stands for print line, okay? Now inside of these brackets here, we can print a string or whatever we want to print. So a string in Java is anything encapsulated by 2 quotation marks. So whenever we're printing something, we want to do it in 2 quotation marks, at least for right now. And in this case, I'm going to say the classic hello world with an exclamation point, okay? Now, At the end of every line we write in Java, with exception of lines that start or end with curly braces, we need to put a semicolon. And now you can see once I put the semicolon that our system.out.println gets highlighted, and we can see that it now has syntax highlighting. And syntax pretty much means any code that we write in the program. So we have to make sure that whenever we're done writing a line, we terminate that with a semicolon. Okay, so now we've officially written our first program. All it does is print hello world to the screen, but how can we run this? So first we're gonna have to save, so I'm gonna hit Control S. And to run this, there's a little green button up here and it says run main.java. So we're going to click that. And you can see that down here, a little thing popped up called console, and we printed to the screen, hello world. Now we have officially created our first Java application, very simple. And that is how we go about setting up a new class, and everything that we write for right now, again, remember, is going to happen inside this method. That's what we're calling it. I'm going to explain that later. Public static void main. We have to put it in here. Now, if you want to print another line, you want to print something else after, we can do that. I'll show you how that works. So I'm going to say system.out.println, and I'll say like hello world 2. And if I save this and run again, we get hello world and hello world 2. So you can see we are right where we left off with printing 2 lines, hello world and hello world 2 to the screen. And in this video, I'm going to be going over variables and data types, the absolute fundamentals we have to understand before we can move on to anything more complex. So let's talk about what a variable is. Now, a variable, just like in mathematics, is something that holds a value. Now, in our case, that doesn't have to be just a number. It could be a string, it could be a Boolean, an integer. Like, we're going to talk about the different values, and those are what are known as data types or objects. So let's start by just creating a variable. To create a variable, we need to first figure out what type our variable is going to be. In this case, I'm going to start with an integer, and then we're going to go through all the different types and talk about what the difference is. So to start, we're going to type int, declaring that this variable that we're about to type out is going to be an integer. We're then going to give a variable name. Now, the variable name should contain typically just letters and underscores. Now, I believe you can use numbers as long as it's at the end, but in our purpose, we're not going to do that. When we create a variable name, you have to make sure you do not use any spaces, and you don't use any special characters as well. So I'll go through a few examples of valid variable names and invalid variable names. So a valid variable name, for example, could be hello. That's valid because we don't have any spaces, we don't have any special characters, and there's no numbers in it, okay? Now, an invalid variable name would be something like hello name, okay? This whole thing, as our variable name, is invalid because it contains a space. Now, if I try to put like a, percent sign like this, or I try to put like an asterisk, that is not a valid variable name. So don't use any special characters. You can end with an underscore. You could start with an underscore if you want to, but we're not going to be doing that in this case. Typically, when you create a variable, if you want to make a name be like 2 words, the way you do it is you type like hello, and then you would do a capital and then the next word, or you would do an underscore representing a space and then the next word. Okay, so that's enough about valid variable names. It's not super important right now. So I'm going to create my first variable, int hello world, and that's going to be equal to, by just putting an equal sign, whatever integer I want. So in this case, I'm going to say 5, and then remember in Java, whenever we end a line, so this is just saying my integer hello world is equal to 5, we need to terminate with a semicolon. So there we go, and we see we get int. Our variable name is now highlighted in yellow, and there's no issues. So if I highlight, let's just see what it says. This is never used. Okay, that's fine. So we've officially created a variable. The variable name hello world now points to the integer 5. So to prove this to you, I am simply going to print out the value of hello world like this. Okay, so I'm going to say system.out, oh, it's a comma, isn't it? System.out.println, and what we're going to do is we're going to say, okay, so hello underscore world, that's our variable name, and that variable holds 5. So when we print this, we should be printing 5. The way this works in the computer, right, is it says, okay, hello world, let's see where hello world is. It's up here. All right, hello world is equal to 5, so we print that. Okay, so there we go, and we get 5 printed down here in the bottom of the screen. Now I want to show you something quickly, and this is just going to go, this is a really important fundamental thing that a lot of people don't talk about in programming tutorials. And it's kind of like order of operations or execution. So I am going to now put my variable underneath my system.out.println. Okay, so I'm first going to print hello world, and then I'm going to set hello world equal to 5. Hopefully you guys have realized what the issue might be here. If not, I'll talk about it really quickly. And the problem is that I am trying to print the value of hello world before I've declared it, because in programming, the way things work is, unless you otherwise specify, we're going to be reading from top to bottom and left to right, just the way you'd read a book, right? So we first read this line, system.out.println, hello world, and then we create hello world. So here we don't know what hello world is. So if we try to do this, you can see it warns me there's an error. I'm going to say, okay, you know what, there's an error, let's proceed anyways. And you can see that down here we get a bunch of red text, and it says, what do you call it? Hello world cannot be resolved to a variable because we haven't yet declared that variable. So we have to make sure whenever we're referencing or using variables that we first have them declared somewhere above our like the line that we're using them in. Okay, so there we go. We've created a variable hello world. We print that to the screen. Now let's create a few different variables and talk about what these types are. So in case I didn't really specify, int stands for integer, and that pretty much stands for any number that does not have a decimal point. So as soon as I put a decimal like this, like 5.0, this actually becomes a new data type, and that data type is called a float. Now float stands for floating decimal point, which means any number that has a floating decimal point. So I'm going to say float, let's see, num2 is going to be my variable name, is equal to, and in this case I'm going to say 5.0. What's the issue here? Add cast from double to, okay, 1 second. We're just gonna say double. Okay, sorry, I made a mistake there. We're just gonna type double here as the name, okay? Not float. Don't worry about float right now. We'll talk about that later. So anyways, we have double num2 equals 5.0. Now double is exactly what I was explaining before. Anything that has a floating decimal point. So even though this is still the exact same value as this in terms of mathematics, because it has a floating decimal point in our computer, it is referenced as a double, okay? Now, there's some other data types as well that we're going to talk about. So we have int, we have double, we also have something called Boolean. Now, Boolean is true or false, and these are going to be really important in the next few videos that we talk about. So Boolean, I'm just going to say b as my variable name, is going to be equal to, and in this case, I'm going to say true, and again, make sure I'm putting my semicolon. Now, there's only two values that a Boolean data type can have. That is true or false. Now, why these are important is because based on the value of a Boolean type, we're going to be doing things later in our program. Like if b was equal to true, we're going to print something, otherwise we won't print something. So that's really important. So another data type that we have is known as char. Now, char is any character, okay? So this is a little bit different from a string that I talked about in the last video, but I'm going to talk about string as well. So I'm going to say char c is equal to, and whenever we create a character, there's two ways that we can do it. We can do it with Unicode, which you probably don't know what that is, or we could do it with single quotation marks. So by just simply hitting the single quotation marks, we can put one letter in the single quotation marks, and that is a character, because that's what char stands for, a character. So like something on your keyboard in quotation marks. Now a character could be, for example, 9 in quotation marks. So that's still a valid character because it's in quotation marks. It's different than the number like 9 if I were to type that up here, okay? So any letter or character that goes in quotation marks is a char. Now we have to be careful because chars can only be one character. If I try to do like 03, you can see that we're getting red text and Java's yelling at us and it's saying, no, that's not allowed, because we can only have one thing. All right, now I just want to show you, I want to go over again really quickly what the main difference is between this 9 and this 9. Up here, we've declared we're going to have an integer named hello world, and it's set equal to 9, okay? That's what it is. This is a character, and since it's in quotation marks, this is not the same thing as 9. The way, like, the data types really do matter in this sense, okay? So I'm just going to change this back to, like, H or something for now, okay? Char C equals H. So that is extremely important. Now, string. This is another data type. It's a different kind of data type, which we'll talk about in a second. But to make a string, we do string, I believe with a capital, we'll see. And then we give a name. So for our variable, in this case, I'm just going to say str is equal to, and then this time for string, we use double quotation marks, okay? And I'm just going to say Tim in here. So chars, single quotation marks, and strings are double quotation marks, okay? And strings can contain anything in them. So I could have like 6, 7, 3 underscore star. That's a completely valid string. We can put any characters as long as they're within inside of these quotation marks, okay? Same thing with the character. If you put a 9 in a string, this is different than a 9 like this, okay? So these are our main data types. There are a few other ones, but I'm not going to go into them right now because they I don't know, they're a bit more complex than we can handle right now. So pretty much though, you might notice that this string is highlighted as a different color than these. You can see int is orange, double is orange, boolean is orange, char is orange. Why is string blue? Now the reason it's blue is because it's a different type of data type. These 4 data types that I talked about up top here are known as primitive, and wow, I really just did that. I'm used to typing Python. Primitive data types, okay? And what that stands for is not changeable, okay? And we're gonna talk more about primitive data types and not primitive data types later on, but just know that these ones that I talked about here are known as primitive in Java, and this one is not primitive, okay? So anyways, let's just see now, printing out like some of these data types, like what we get when we print them to the screen, right? So if I print, for example, C to the screen, well, you should guess what we're gonna get. We get H, because that's C. If we print str, we get 9, and so on. Now, last thing I want to show you with variables is that we can actually make variables equal to other variables, and we can add variables, and we can subtract variables. And that's what we're going to be doing a lot in the next video, but I want to just quickly introduce you. So for example, I want to create a new integer, okay? I'm going to say new integer, and I'm going to call it, let's just call it Tim, why not? Now, I want this integer to be equal to 9, okay? But I don't want to type 9 out. What I'm going to do is I'm actually going to type hello underscore world like this. Now what we've essentially done is we've taken the value from hello world and we've assigned it to Tim. So now if we were to print Tim to the screen, we get the value 9. Now if I want to print hello world to the screen, you can see that we are still getting the value of 9. So now Tim points to hello world, which points to 9, right? So Tim is equal to 9 and hello world is equal to 9. And we can do that, and we can add variables together, we can subtract variables, we can do all kinds of cool things, and that's really the point of variables, right? So we just have to make sure when we're doing this, for example, that we don't do something like this. String Tim equals hello world. You can see here now it says cannot convert from int to string because the data type string is obviously not the same as 9. So we can't do that until we learn about something called typecasting, which will be in a future video. Now in this video, I'm going to be adding on to some of the stuff I did with variables in the last video, and I am going to be talking about basic operations like plus, minus, subtraction, division, exponential, all of that fun stuff. So without further ado, let's get started. Now what I'm first going to do is just talk about another way that we can create variables in Java. So earlier you saw me do something like this, int x equals 6, okay? This is fine, this works, we already know this, but there's another way that we can actually create this variable. And to do that, we can actually omit this equals 6. So if we do this and we just say int x, what happens now is we've declared that x is a variable, it exists, but we have not given it a value. So we've declared it, but we have not initialized it. I'll show you what I mean by this by just doing system.out.println, and we're simply going to print x and just see what we get. Oh, it probably help if I spelled print correctly. Okay. Wow, I really messed that one up. Println. Okay, run this, and you can see we are already warned that there is an error, so we'll proceed. And it says the local variable x may not have been initialized. So before we can actually use the variable x when we set it up like this, we have to initialize it. Now to do that, any line underneath this declaration, we can just say x is equal to, and then whatever value we want it to be, as long as it's an integer value. So in this case, I'm going to say x equals 6. And now if we run the program, everything works fine, and we get 6. Now obviously we can do this with every data type. So if I do like char and char x, right, and that's fine, and I say char x equals single quotation marks f, like that, okay? Then we can print that out, and that will work fine. Now, what I want to talk about now is operations. So I am going to create a few variables. I'm going to say integer x equals 5, don't forget your semicolon, integer y equals 7, and I'll say int z is equal to 56, okay? And I'll create one more variable, and this is where we're going to start talking. So what I want to do now is I want to sum all of these variables, so 56, 7, and 5. But I don't want to write like 56 plus 7 plus 5, okay? Because yeah, that's the value of these variables. This works fine. But what if I were to change this variable y? Well, that means I have to go down here and I have to change this as well to whatever I changed y to. What if I want to change x and y? Well, that means I have to change both of these. So there's a really cool thing that we can do, and we can just use the variable names and just add them up. So we can say x plus y plus z, like this, okay? And now our variable sum stores the value of the sum of these three variables. And to prove it to you, I will print it to the screen, and you can see that we get 68 as our sum. Now, furthermore, if we wanted to take the difference of all these and subtract them, all we have to do is simply replace this with a minus sign, and we get negative 58, okay? Now to multiply things, this is another operator. We can do multiplication like this, and I'll replace this one with multiplication, and we'll multiply all these out together. You can see we get 1960 as our value. To divide, we can use the /. Now, I'm not going to do that right now because that is kind of a different topic. Like, there's a weird thing with division I have to talk about, but that's how you do that. So those are 4 basic operators. Now, these work just like they work in math in terms of order of operations, right? So we're going to start off with exponents and then go brackets, exponents, division, multiplication, and so on through the process, okay? I assume you guys know order of operations. So that means if I do something like x times y minus z, what's first going to operate is x multiplied by y, and then we are going to subtract z from whatever this value is. Now, again, if I switch this and I go like y multiplied by z, what's going to happen first is y multiplied by z, and then the subtraction is going to happen. Now, for example, if we have the operators that have the same precedence or the same, I don't know, like order of operation level, I don't know what to call it, it's just going to operate from left to right. So it's going to do x multiplied by y multiplied by z. So this is a common occurrence. A lot of people don't understand this. If we do a division sign, we're first going to multiply x times y, and then we're going to divide by z afterwards, okay? So that's how that works. Now, whenever we're doing operations like this, we can also add brackets in. So if I wanted to, for example, say x multiplied by y and then divided by z, I could do something like this by throwing brackets in here. So now it's showing 100% that we're going to multiply this before we divide. And same thing if I did this. Now whatever's in the brackets is going to happen first, and then I can divide by z. And obviously we can embed more brackets in here. So I can say like multiplied by y times y, okay? Like, you can add as many brackets and layers as you want, and that's totally acceptable, and that totally works, okay? So now we are going to talk about division more specifically, and then go into a few more operators, because division works a little bit different in Java, I guess, just in general, okay? So if I want to divide 56 by 7, so I want to divide z by y, okay? And I sum, let's just do u, okay? We're going to call this u. And I print this out to the screen. 56 divided by 7 gives me a value of 8. That is because our data type for the variable u, which is holding the value of z and y, or z divided by y, is an integer. So it actually isn't able to give us a floating point number, although we know that this number is a floating point number. Or is it? Let's see. Let's make sure this is, I'm not messing up, 57 divided by this, okay? Yeah, so it can't give us a floating point number because this is, well, an int data type. So it assumes that we want an integer in return, so therefore it's just going to give us the value and terminate all the decimals, okay? So say this number is like 8 point something, just gives us 8, right? Removes the remainder. Now, if I want to get decimal points, which you will want to do most of the time, I could try to do something like this, okay? Double of u equals z divided by y. And you mean, okay, that makes sense, double, like it's going to give us the floating point. But watch what happens. If I run this, we just get 8.0. Well, we know that 57 divided by 7 is not 8.0. It has some decimal component to it that I couldn't tell you right now. But why aren't we getting that? Well, that is because the two data types that we are dividing are both integers. which means when we get a value back from this, it's going to be an integer value. And then all we do is convert it into a double because we have this double here, okay? Just by adding that .0. So how can we ensure that we get a floating point? Well, there's two things we could do. We could first change the bottom to be a double, and we could change the top to be a double. So I could do like this, okay? Like it's like double, and could change this to be a double. All right, and if we have both of these double, and we try this now, you can see that we get our decimal point, okay? And it shows up and gives us like whatever that is. Now, what if I just make one of these? So I say int y, and this is double. Let's try this now. You can see we still get our floating point. That is because if one of the values that we're dividing here is a double, it's going to automatically make the whole thing a double. So if one of them is a double, everything becomes a double. And this is the way it works for all of the operations. So if you have double u, and in this case we say like x times y, or let's say x times z, since z is a double, x is not, we're still going to get a double value. So if we run this, you can see that we get this little 0.0. So if one of our operands is a double, then that means everything is going to be a double when we use it or whatever, okay? Now, exponent, the way that we can do exponent is we have to bring in module, I believe, but it's like math.pow, and then in here you put the, what do you call it, the base and the exponent. There's not a star like in most languages, okay? I'm gonna say int of d is equal to math.pow, and here I'm simply going to raise x to the power y. All right, so we get math.pow. Let's see, what is this saying? Convert, okay, so let's do this. Int, cannot convert form double to form int. Interesting why it's telling me that. Let's just try this maybe. There we go. Okay, so whenever we get exponents, apparently they have to be in the form double. Okay, didn't know that, but all right. So now if I want to print out d, what's going to happen is we get the exponent for this. Okay, so math.pow, this is your base, and this is what you're raising the exponent to. So 5 to the 7 apparently is equal to that. Okay, so that is pretty much it for operators, I guess. Obviously, you can have as many operators in one line as you want. You now understand how things work in terms of doubles and ints. So if one of the operators in the whole chain of operators variables that you're adding, subtracting, dividing, whatever, is a double, then that means you're going to get a double value back for 100%. If all of them are integers, that means you're going to get an integer value back. Now, same thing here. So I have, let's change y back to double, and let's change u to be int. Okay, so it says int u x times z. So now it's x times y. Okay, so now you can see we're getting an error here. Cannot convert from double to int, and that is because we're trying to say that the integer u is equal to x times y, but y is a double value. So when we get a value back here, it's going to be double. So we can't convert that into an integer just by doing this. And there's another way that we can do it that I'm going to show you in a second. Okay. So we would have to make sure that this stays as double. And it's nice in this IDE, it tells you when you made a mistake like that, because a lot of times you might not really see that in your program, okay? Now, I'm quickly going to go over something called typecasting. We're going to talk about this a lot more later, but I'm just going to show you like fairly quickly how this works. I'm just going to delete this line, and we're going to turn these back into integers. Okay, so if I want to do something like x divided by y, okay? And I want to make sure that I'm getting that value, the decimal point value, okay, like so a double. Rather than converting these, like the declaration of our variable, to a double, something we can do called typecasting. And to typecast, we are changing in line without changing the declaration, the type of the variable. The way to do this is to simply put in brackets the type that you want to convert your variable into, and then directly afterwards is the variable you want to convert. So in this case, it's double, and then we have y. Okay, so if I run this now and I print u instead of d, you can see that we get the decimal value that we were looking for. If I remove this double, right, then we do not get that. Or we do just because it says double, but you guys see the point, okay? So in this video, I'm just going to be teaching you one more operator that I forgot to mention in the last video, and we're going to be talking about getting input from the user using something called a scanner. Now this scanner is going to allow us to grab like text, numbers, strings, all that fun stuff from the user, and then do something with that input. And that is kind of the basis of programming, right? Based on what a user does, we want to do something in most cases. So the first thing that we're going to do is just teach this other operator. It is the remainder operator. It's not going to take me very long. In this case, I'm just going to say int x is equal to 56 modulus, and this is what the name of the operator is, modulus. It's simply a percent sign. Pick a number. In this case, I'm going to pick 5. Okay, so what this remainder operator does, it's called modulus, okay? Some people like to call it a remainder operator, and it's simply a percent sign. It gives us the remainder of this division. So this division is actually equal to, 56 divided by 5 should give us 11. Okay, 11 remainder 1 is what this division actually is equal to. So if we print x, we should get a value of 1. And there we go. And that's literally all the remainder operator is. Gives you the remainder of a division. I don't think I need to talk about it too much more. I'm sure you guys want to get into the input, so I will leave that alone for now. Okay, so let's get rid of this line. And now let's talk about how we can get input. So using a scanner is what we're going to do. So the first thing we need to actually do is at the top of your program, you might notice I have a new line here. Now this says import java.util.scanner. I need you guys to type this out for me, java.util.scanner. Make sure you add your semicolon, because this is what we're going to be using to get input. And whenever we use certain tools in Java, we need to import them at the top of our program so that we can simply just type like certain data types. And we'll get into this later when we talk about classes and methods and all that stuff. Okay, so once we've done that, we need to set up a new scanner object. So we're going to type scanner. The name of our scanner, I'm just going to say sc, is equal to a new scanner. And inside of the scanner, we're going to type system.in, okay, in this brackets. This might seem confusing, but all this is doing is it's saying scanner is a data type, just like string is a data type, just like Booleans a data type. Okay, it's a different type of data type, but it is in a data type. Its name is sc. And instead of typing like 1 or like putting quotation marks and typing a string, we're going to say, well, it's equal to a new scanner. And what this scanner is going to be is system.in, which means typing on your keyboard. And there's different types of scanners, which we'll get into later, not in this video. So once we've set up our scanner, we need to actually use the scanner. So how can we do this? So what I'm going to type now is I'm going to say, let's say string scanned is equal to sc.next, and I think we can just use next. Yeah. So what this does is we're creating a new variable string. It's a string type called scanned, and it is going to get the next stream of input from this scanner object. Okay, so sc.next is what allows us to get a string from the user. So I'm just going to print out scanned after we get it, because I want to show you what happens. So I'm just going to run the program in Illustrator and we'll talk about it. So now you can see if I go down here, my cursor shows up and I'm able to type. So in this case, I'm going to type hello. Okay, watch what happens when I hit enter. It prints hello underneath it. So hello, which we typed in, was the input. It got scanned in by this scanner object using sc.next. It got stored in the variable scanned, and then we were able to print scanned out to the screen. Okay, pretty straightforward. That's how it works with strings. Now watch this. If I type 1 works fine, but I just need to show you that. Now I'm going to do this with int. Okay, so I'm going to say int scanned equals sc.next. Well, what's happening? What's wrong? Well, the issue right now is we are trying to turn a string, which is what this returns to us, into an integer. So we can't actually do that, because what per se, okay, proceed, we just run into an error. We cannot convert from string to int, because what this method gives us is a string. Now, if we wanted to be able to get an integer from the user for them typing in, we have to use another method, okay? And this one is called nextInt. And now you can see we're getting no more red lines. Everything seems to be working fine. sc.nextInt. And if we run this, then we type like 54. That works fine. Prints that out for us. Watch what happens though if I try to type in something like hello. So there's no errors right now. Like Java's not telling us there's anything wrong. If I type hello, we get an issue. Now that's because this was expecting me to type in a integer. And what happens in here, like this little line of code, what it actually does is it tries to convert what I'm typing in, which automatically comes in as a string, into an integer. So when it tried to do this, it tried to convert hello into an integer, and no one, not you, not you or me, knows how to convert hello into an integer. So it threw us an error and it said, no, that's not allowed. You can't do that. So I'll show you what we can do now if we want to get Booleans and other types, and I'll show you a way to work around an error like this, okay? So if we want to get a Boolean value, we could type Boolean scanned equals next. And would you look at this? Boolean. That's literally the name to get a Boolean. sc.nextBoolean, okay? So let's run this. Now note, a Boolean has to be true, spelled correctly, or false with lowercases, I'm pretty sure. So true, that works fine. But if I try to type like hello or 5 or something in there, that's going to crash. It's going to give us an issue, okay? So Boolean, that's how you do that one. If we want to get a double, we could do double equals next. And guess what this one is? Next double. There you go. And now it's going to expect a number of some sort. So like 6 would work fine, but I'm just going to do 6.3, and it prints out 6.3. Let's actually just test 6. If you do 6, yeah, it just gives us 6.0, so that works fine, okay, to getting doubles. Now I want to work around the issue of what happens, like we get that crash, okay? We don't want that crash. So how can we fix that if, per se, when it's expecting a double, I type in like hello? Well, what we should do is always get a string. So we should always say sc.next and always turn this into a string. And that's because a string can be anything. Like anything we type in here is fine to be a string, because remember, a string is simply anything in double quotation marks. So if I type true, although yeah, we know it's a Boolean, it's in the quotation marks, so it's really a string, okay? If I type 1, that's a string. Type 1.6, it's a string. Like anything can be converted into a string, pretty much. So that works fine for us. Now, once we have it as a string, we can then convert it into an integer. Sorry, I had to take a quick cut there. But what we're going to do now is we are going to attempt to convert this value into a different type. So in our case, I want to convert it into an integer. So a way that we can do that is we first need to set up a variable. So I'm going to say int x in this case is equal to scanned. Now I need to put something with this scanned. I can't just say int x equals scanned. I can't just do that. It's not just going to be able to convert that for me. It doesn't know how to do that. So what we need to do here is actually do we need to type here integer dot parse int, okay? And then inside of the brackets for parse int, we're going to put scanned. And what this is going to allow us to do is, well, convert into an integer. And if you guys just highlight over this, if you don't know what it does, you can actually read through the definitions. In this case, it's going to say parses the string argument as a signed decimal integer. The character in the string must be all decimal digits, except the first character may be an ASCII minus sign. Okay, so it tells you exactly what this does. It tells you what integer does. Integer is a class. So yeah, they'll convert that for us. So then if I wanted to print x to the screen, that would work fine. Now the thing is though, and this is what we're going to be doing in the next video, is we still run into the same issue, because again, like now if I type something like hello, we still get a crash, because how do we convert hello into an integer? Well, we should really first check if the value is an integer, and I'm going to be showing you in the next video, I believe, the next one or the one after that, how we can actually do that using if statements and else statements and error catching later on. So stay tuned for that, but this is the way for right now. If you know you're going to be getting an integer, that you can convert it in, or obviously you could just do next int and turn this to an int like that, and everything works fine for you. So in this video, we're going to be talking about comparison operators. So like greater than, less than, equal to, not. We're going to be talking about chaining conditionals together, which you'll see if you don't really understand what that is right now throughout the video, and how we can use those Boolean variables to do certain things for us. So that's what we talked about in the first few videos. And if you guys don't really know what the point of Boolean is, well, this video will show you. So without further ado, let's get started. So I'm just going to start out by typing a few numbers here, because this is just the easiest way to compare things to start, and then we'll do some other stuff. So I'm just going to create 3 variables that are integers. X is 6, Y is 7, and Z is 10. Now I'm going to create a Boolean variable, so Boolean, let's call it compare, and we'll just set that blank for right now. So what I want to do is I want to compare X and Y and Z using some different comparison operators. So in Java, I'm going to write them out here. We have, I believe, 4 main comparison operators, 4 or 5. So I'll type them out and we can see. So the first one is greater than, and then we have less than, we have equal to, we have greater than or equal to, less than or equal to, and not equal to. Now, I know I just went through those fast, but they're pretty straightforward. This is simply going to state whether something is greater than the other thing. This is less than the other thing, or whatever way you have it, right? This is equal to. So the double equal sign is different than the single equal sign. Double equal sign is when you're comparing 2 values to see if they're the same, and the single equal sign, like this one here, is if you're assigning a value. So make sure you remember that, because a lot of people, when they compare things, they forget to add the other equal sign, and they just use one, and they end up running into some issues. Okay, so greater than or equal to, pretty straightforward. Less than or equal to, same thing. And not equal to is an exclamation point and an equal sign. Now I'm going to go through these and show what all these do. So I guess I'll leave that there. And because I just remember that I have been forgetting to teach you this, if you do 2 slashes in Java, this stands for a comment. And a comment is simply something that the computer is going to ignore, and it's just there for the programmer, so that they can look at it and be like, okay, this is what this line of code does. Whatever, the computer doesn't care. So whenever it sees a line that starts with 2 slashes, this is how you do a comment. It just ignores that line and moves on. So that's simply what a comment is, and it just grays out in here to show us that that's a comment. Okay, so compare. So I want to compare x and y, and I want to see if x is less than y. So say if x is less than y. And what this statement right here that we're typing here is going to return a value of either true or false. So we can look at this. We say, well, 6, is that less than 7? Yes, it is. So that should give us a value of true. So if we print compare to the screen, then you can see we get true like that. Now, if I flip this around and I say greater than, okay, what do you think we're going to get? Well, we get false. It's pretty straightforward. To compare the 2 values to see if they're the same, we can do 2 equal signs, and in this case we get false. And now this comparison operator, some people get confused by, but if I do not equal to, what this is going to tell me is if the 2 values, so on the left side and the right side of the comparison operator, are not the same. So if they're not the same, I get true. If they are the same, I get false. So in this case, they're not the same, so we should be getting true, okay? And I guess I could show you greater than and equal to, but they're pretty straightforward in terms of how they work, at least on numbers, okay? Now, these work fine, so greater than or equal to, less than or equal to on numbers. But what if I want to compare strings? So I'm just going to change x and y. I'm just going to make 2 strings here. I'll say, string x, we'll say hello, and string y, and this is equal to hi, okay? So see, now I'm getting this blurred out, or this red line here. It's saying the comparison operator greater than or equal to is undefined for strings. So the only ones that I'm allowed to do on strings, at least for right now, that we're going to talk about, are 2 equal signs or not equal to, okay? And not equal to is simply going to say, right, if the strings are not the same and if they are the same. So in this case, I say not the same, I'm going to get true. If I try to say if they are the same, I get false. Now, I want to just show you one thing here. If I type hello and I add a capital O at the end of hello like this, do we think that this is the same as hello with all lowercases or not? Well, I'll show you. It is not. So capital letters do matter in programming, right? And that's the same with variable names. Like the capital variable y is different than the lowercase variable y, okay? So that's how we can compare those. And I want to see, actually, can we use greater than? No, we can't use greater than or less than on strings either. Okay, so what I'm going to do now is I want to chain multiple conditions together. So I'm going to show you the AND operator, the OR operator, and the NOT operator. And these are how we can add multiple conditions together to get one like main condition, if that makes sense. So I'm going to change these back to numbers. It might be faster just to type them out. Int x equals, what did I have, 6. Int y equals, let's just do like 23, why not, okay? So now I'm going to compare multiple things at once. So I first want to compare if x is greater than y, but I also want to compare if z is greater than x. Say I want to check 2 things, perfectly viable. In many cases, you'd want to do that. The way that we can do that in Java to compare if 2 things are the same is using this AND operator, and the AND operator looks like this. So it's these 2 AND signs, okay? And then we have to add another condition after this. In this case, I'm going to say if z is, let's just say z is less than y, okay? You can see that's fine, we're not getting any red lines. And what this does is it's going to compare the operation on the left side, it's going to do the comparison on the right side, and then we're going to end up getting two values. So in this case, x is greater than y, so 6, is that greater than y? No, we're going to get false. So I'll just type it out as if this is what's happening in the computer, right? And then is z less than y? Yes, it is. So we get true, like this, okay? Now, we have a false and we have a true, but we have this AND operator in between them. What this AND operator is going to do is it's going to check if both of the conditions on the left side and the right side are true. If they are both true, it returns true to us. If they're both, or if one of them is false or both of them are false, then we get a false value. So in this case, since this one is false, we're going to get a false value because both of them have to be true for this to evaluate to true. So I'll show you if I do this. Okay, and I print this to the screen, you can see we get a false value because this is saying if this and this are true, then the whole thing is true. Okay, now another operator that we have is the OR operator. And the OR operator is two straight up lines like this. I don't know what they're actually called, the key for that, but anyways. So this is going to do kind of, it's similar to AND, but in the other way around. If one of the two conditions are true, the whole thing is going to be true. Otherwise, if both of them are false, it's false, right? So the way that we can determine this again, right, is we'll do this condition, we'll see what this is equal to, and then we'll see what this is equal to, and if one of them are true, we get a true value. So let's run, and there we go. You see, we get a true value. Now, we have a NOT operator. Now, what NOT does is simply going to reverse anything. And this is the way I like to think about it. Whatever you have, if you see the NOT, just reverse it. So what this does is it's going to say if this condition is not true, then we get false. Or if this condition is false, sorry, so not true, then we get true. Other way around, if this condition is true, then it's false. Because it's checking if it's not true. I hope that makes sense. You kind of just have to play with it to make sense of it. But in this case, since we get a true value, and we have this exclamation point, which is our NOT operator, it is going to give us false. So you can see here, we get false. Now, if in here I were to put a false value, so literally, I'll just show you by typing in the value. I say NOT and then false in there, you can see that we get a true value. So it simply just reverses like anything that you're looking at. Now, I want to show you that we can actually combine all of these operators together. So what we can do is we can use like ands and ors, and we can have an infinitely long chain of a condition that will eventually evaluate to true. Now, this is actually some kind of like math problems you have to do. Typically in university, I'm going to have to do it next semester, where you have like a ton of different conditions and you have to figure out if you're going to get true or false based on them. So I'll show you like a pretty basic example. So I'll say if x is less than y and y is greater than z, or z plus 2 is less than 5, or what do you call it, like x plus 7 is greater than y. Okay, so I just typed a bunch of conditions, right? How do we determine which of these are going to evaluate first? Well, that is a good question, and typically you'd never type it like this, because just looking at this, like even I'm looking at it right now after I just typed it, and I'm like, wow, okay, how do I determine which one of these is going to happen first? Typically you put things in brackets. So I would say something like this. It's like x and y. Okay, so I have this first condition now, right? You put in brackets, it's going to evaluate this, and in this case we'll get, I'm not going to bother doing the actual evaluation, but let's say we get true, okay? Or, so we have true, or whatever this evaluated with this is. So what this is going to do now is it's going to look at z plus 2 if that's less than 5. If that's true, then we get true, or, and then whatever this is, and then we could treat this as if this is in brackets like this, okay? So now the way that this would work is we do everything in brackets here, we get a value of like true or false. We do everything in brackets here, we get a value of true or false, and then we'd see if either of them are true and return that value. So you know what, let's just print it to see what we get. We get true, okay, I don't even know how that worked, to be honest. And yeah, that's how we could do that. And we can also throw knots in here too. So if I wanted to throw a knot like this, then we can do that. Now, typically, you're not going to see massive chained conditionals like this because of the exact problem we're running into. It's difficult to determine what they are by just reading it. And you'll see when we go into if and else statements in the next video, how we can use these conditions to evaluate certain things. I just wanted to show you that you can combine multiple things. And for example, I don't only have to use variables. You can see that here I put z plus 2 less than 5. That's a perfectly valid condition That works perfectly fine. Could change this is equal to 5, right? You can add constants. Like I could just say 2 is equal to 5 if I wanted to. That's fine. You can compare with constants, and with strings, just remember you can do less than or equal to, or sorry, not less than, not equal to or equal to, and you can compare floats with ints, and you'll see as we continue going through the video. It's too long to go through all of them right now. In this video, we're going to be going over if, else, and elif statements in Java. So quickly, I want to fix a really small mistake I made in the last video. So if you guys don't know, I am like a Python programmer typically. So I'm doing Java obviously, but Python is like my first language. So I'm used to being able to use 2 equal signs on pretty much anything because that's what you can do in Python. But in the last video, I showed you using 2 equal signs on strings. Now that's not incorrect to do that, but it's not going to work the way you think right now. So if you want to compare if 2 strings are logically the same, like the actual string values are the same, what you should actually do is say you have a string, so s in this case, you have to do dot equals, okay? And then inside of this equals here, you're going to put the string that you want to compare it to, or you're going to put another variable, which is a string. So in this case, if I wanted to say if like my scanner object, which I've just typed out before this video, is equal to hello, this is how I would do it with this dot equal sign, not the 2 equal signs. The 2 equal signs isn't wrong, but it's going to give you a different answer, and we will talk about that in future videos, but it's too advanced to go into right now. So just remember, if you want to compare 2 strings, use dot equals. My apologies about that from the last video. So what we want to do now is we're going to be using if and else statements. So pretty much, if something happens, do this. Otherwise, do this. And this is the basis of programming, using conditions based on like user input or based on certain events that happen. We're going to do different things, right? So they're really important to understand. So first of all, what I'm doing here is I'm just setting up a new scanner object. I'm just going to get input from the user. We've already talked about this. And what I want to do is I want to check that user's input, and based on what they type in, I want to do something. So the basic syntax for if and else's in Java is you simply type if, you put brackets, and inside of these brackets is going to be your condition. And this is why I spent so much time talking about conditions in the last video. The condition here is if this condition evaluates to true, whatever's inside of what I'm about to show you here, whatever's inside of these curly braces is going to happen. So let's start with the condition. I'm going to say if s dot equals, not 2 equal signs, and in this case, I'm going to say Tim. So if the user types in Tim, when we prompt them for input, then I want to do something. And what's going to happen is inside of these curly braces, and this denotes a block. So this is known as like an if statement or an if block. So this block simply goes the syntax if, then we have this these brackets. Inside the brackets is a condition. The condition can be as long as it wants, as long as you want, as long as you're going to get a true or false value back from it. And then we have these curly braces, so an open brace and a closed brace. And inside of these braces, anything that I type in here is going to happen if this condition is true. So let's just do a quick little test here, and I'm just going to do system.out.println, and in this case we'll just say you typed Tim. Okay, wow, you typed Tim. Okay, and let's run the program and see what happens. So when I run this, if it loads up, that's odd. Okay, give me 1 second. Okay, so we're back. I accidentally closed my console, and yeah, we were running into some issues with that. So I got that up and running now. Let me just restart this quickly. Okay. Wow, okay, I don't know why that's white, but anyways, let's just type out, I don't know, what are we going to say here? Let's type hello and see what we get. Well, we get nothing because we didn't type Tim. So let's run it again. Let's try, and this time I typed Tim, and it says you typed Tim. So there we go. Our basic if statement is working. Now I want to just put another system.out over here so that we can see what happens when we have, like, just with this example, okay? I'm just going to print, I'm literally going to print, okay? So now what I want to show what happens here is, like, what is the program going to run? So if we type Tim, we're going to get this you type Tim, but are we still going to get this print out here, or are we not going to get it? Well, let's test this out and see, okay? So in this case, I type Tim. So when I type Tim, it says you type Tim, and then it says print, okay? Now the reason that happens is because this print is not within this if block, right? So it's just going to execute simply after this if block happens. So now same thing, right? If I type like hi, it's still going to print out print to the screen because, right, it didn't go through this if block, but this is not inside of the if block or the if statement or whatever, so that executes. Okay, so that's pretty straightforward. Now I'm going to show you else and else if. We're going to start with else. So else is very straightforward. It can only come after an else if or an if. So like the start of the block has to be if, and then this else, you can't just have it like alone. It has to come after an if statement or an else if statement, which we're going to go into in a second, okay? There's different ways to format this. Some people like to put the else like this, so it has the closing brace and then the open brace. I personally like to do it like this. Some people like to do it like this. It's however you want, okay? This just works fine. Just make sure that your curly brace doesn't look something like that all the way out there, because that's kind of hard to read, okay? So what I'm going to do now is I'm going to put this print statement, and I'm going to put it in my else statement, all right? Now, the way this else works is if this happens, that's fine. We're going to go in here, we're going to print this out, and then we'll move down to the end of the block. So we'll go to here as our next execution line. Now, if this doesn't happen, so other words or else, then we print this. So we're either printing you type Tim or print. We're never printing both because one of them is if and one of them is else. All right, so let's test this out. If I type Tim, we get you type Tim, okay? If I type anything else, so like some random letters, and I hit enter, you get print. So the way this else works is it's meant to do something if this condition is not true, right? Okay, so that's pretty straightforward. I don't think I need to talk about that anymore. The next one I'm going to show you is else if. Now, this is a way that we can add multiple if conditions in one kind of block, okay? So what I can do now is I can do like else if, and now it's the exact same syntax as a regular if statement, except you just have this else before. And obviously, since this is an else, it has to come after an initial if statement. So you can have as many of these else ifs as you want. Now, first I'll just put a condition in here. So I'll say s dot equals, and in this case, let's just say like hello, okay? And then in here, we'll just do system dot out dot println, and we'll just say hi, because we want to greet them back. They said hello. Okay, so again, the way this is going to work is we're going to go through. We're going to check. We're going to get our scanner input. We get s. Say, okay, what's s? Is s equal to Tim? If it is, we're going to print this, and then we're going to move down after the last else statement. We're not going to even bother checking if it's something else, because if it's equal to Tim, then we know that we shouldn't bother looking at the else ifs, right? Now, if it's not equal to Tim, what we're going to do is we're going to go through and we're going to check. We're going to say, okay, else if, that's our next block, is it equal to hello? If it's equal to hello, we're going to print hi. We're going to move on with our lives. We're going to move down here. We're not even going to bother going to the else, okay? Now, if it's not equal to hello, we're going to go into the else statement, and we're just simply going to print. There's no condition. It's just automatically going to happen. If you print anything other than hello or Tim, we're going to print. Okay, so let's try this out, and let's type hello, and you can see we get hi. All right, now if I type anything else in here, so like some random letters, we get print. Okay, and that is how that works. Now I can show you, I can add as many else ifs as I want. So if I copy this and I simply paste it down here, I can have another else if, and in here I could have hi, and then in here I could type hello, and we could keep going, and we could do as many else ifs as we want. Just know that whenever you have kind of a block that looks like this, it has to start with an if statement, and it actually doesn't have to end with an else. So an else just should be the last thing. So if you have any else ifs, else will be your last thing. Like I couldn't do an elif here and then try typing. Like that's not okay. You can't do that. But if I omit this else, that's perfectly fine. So now I have, if we type Tim, we type hello, or we type hi. Let's run this, and let's type none of them. Let's type a bunch of letters. We get nothing printed to the screen because we don't have that else statement. Now if I type hi, you see we get hello. Because, right, we went through, it wasn't equal to Tim, it wasn't equal to hello, so we printed hi. Now, I want to show you this. This is a bad example, but it'll work. If I put hello here, and I put hello here, which one are we going to print? So remember, we're only going to print one of these things. We're not going to print more than one. So which one is it? Is it hi, or is it hello? Well, let's test it out. If I type hello in here, we print hi. Now the reason we're printing hi is because this else if is above this one, and this is the first one that's going to be looked at when we type something in, just the way I kind of went through it sequentially. So since we print hi here, well, we're like, okay, well that happened, so there's no point in checking this, and we just move on. Okay, straightforward. Now again, I could do more if statements down here. You could keep typing, like do a bunch of stuff. Just understand you can have as many else ifs as you want. You don't need an else if, like we could just do an if and an else, but every time you have kind of like an if statement or block starting, it has to start with an if. It can have as many else's as you want, and the last thing has to be an else if you're adding the else. You don't have to have that else there. So anyways, I think that's all I'm going to show for if statements, else ifs, and else. They're pretty straightforward. Any condition can go here. So anything that I showed you before, like you could have a really long chained conditional of a ton of stuff. Same thing here. You could have any condition, like it doesn't matter. Anything that gives you a true or false value. You could also literally just type true, and like that would always happen. Okay. In this video, we are going to be kind of taking a step back and just going through everything that we've already learned, summarizing that, putting that into a program to make sure that you guys really understand all of that. And we're also going to be talking about nested statements, so how you can kind of add things within other things, like so if statements within other if statements, variables. And the way I'm going to do this is just by creating a simple program, and what it's going to do is it's going to ask the user to input their age, and then based on that age, we're going to do certain things with that. We're going to tell them, like, I don't know, good examples like on a roller coaster, like if you're 13 or older, you can ride, otherwise you can't. So we're going to do something like that, okay? So I'm going to keep these scanners up here that I have because we want to get the user's age. But before I set up the scanners, I'm just going to print a line to the screen here. So I'm just going to say system.out.print instead of println. And in this case, I will just say input your age simply, okay? So this way it should, if I'm doing this correctly, make it so that we just get the age right after this line, okay? You'll see when we do that in a second. Anyways, what I'm going to do now is I'm just going to kind of start typing, and we'll go through how this works after. So I'm going to say if, and we're actually just going to convert this to an int first, I think. String to an int. Yeah, so using that parse int that I was talking about. So we'll say int age is equal to s dot, or integer. I always forget how to do this. Integer dot parse int. And then in here, we need to type s. So we're going to convert whatever they type into an integer in this case. So we're going to assume that they type in an integer. So we'll say if age is greater than or equal to 13, then we will simply print system.out.println you can ride, okay? Exclamation point. Now, if they're not older than 13, that must mean that they are less than 13 or younger than 13. So in this case, we will simply print that they cannot ride. System.out.println and you cannot ride, exclamation point. Okay, pretty basic program. We kind of gone through how all this works, so let's test it out. Input your age, 5. You cannot ride. Okay, let's try this now. Input your age, do 43. You can ride. Awesome. Okay, so everything's working fine for right now. Now what I'm going to do is I am going to add a else if here, and I'm going to change kind of the problem that we're looking at. So I'm going to say now I want to classify the person based on their age as either an adult, a teenager, or just like younger than a teenager. Okay, I don't know, what do you call those? Whatever younger than teenager is. Okay, so if we are greater than or equal to 18, I want to print you are an adult. Okay. Now, otherwise, so if they are not greater than 18, we want to check if they are less than 18. So, or if they're actually, we'll do it in a cool way that's going to make sense here in a second. So, else if age is not greater than or equal to 18, we know it's less than 18. So all we actually have to check is if they are older than 13, right? Or greater, or older than or equal to 13, because that's what a teenager would be, okay? And the reason we don't have to check if they are, younger is, or if they're older, is because we already know that they're going to be younger than 18. So no, they're within that range. So I already butchered that explanation, but that's okay. So system.out.println, and in this case, we'll just say you are a teenager, okay, like that. And then in this last case, well, we know they're not older than or equal to 18. We know they're not older than or equal to 13. That meaning they must be less than, which is you are not a teenager or an adult, okay, like that. So let's test our program out, make sure everything is working. So if we input an age of 14, we get you are a teenager. Awesome. Okay, let's try it again. If we input an age of 19, get you are an adult. And if we input an age of 0, we get you are not a teenager or an adult. Now I want to show you what happens if I input like a negative number. Like what if I do like -98? You are not a teenager or an adult, because, right, we have this else statement, and that's not greater than or equal to 13. It's not greater than or equal to 18, so we get you are not a teenager or an adult, okay? Now that is pretty straightforward. What I'm going to show you now is how we can ask like another question, or how we can check something else. So what I'm going to do here is I want to say, if they're 18, and only if they're 18, I want to ask them a question. Now, what should the question be? I want to ask them what their favorite food is, okay? So I'm simply going to do now exactly what I've done up here, except just throw it inside of this if statement. So if this happens, we're going to do this, and this is going to show you nesting, okay? So I'm going to say sc, or we'll say string. I guess we can just do int because we're going to assume they're, or string, I guess, because it's going to be food, yeah. We'll say string food is equal to sc dot next line, like this, okay? And what I'm going to do is I'm going to print up here again what we're looking for, so I'll just copy this, save me a second. And in this case, I'll say input your fave food, okay? Now what I want to do is I want to check what their favorite food is. So I want to say if their favorite food is pizza, I'll say mine too. Otherwise, I'll say that's not my favorite food, or something like that, okay? So we'll say if, and we have our condition in here, we'll say if food dot equals, and in this case we'll simply type pizza, right? Then we will system.out dot println, and we'll say mine, wow, inside of the quotes, hopefully, say mine too. And then otherwise, so the else, what we'll do is we'll simply type system.out.println, and in this case, we'll say not mine, okay? So this is showing you now, it looks a bit more complicated, but that we can actually put if statements and else statements, and we can do things with inside of the if statement. And I'll show you that this works. So if I type, I'm 19, it's gonna say input your fave food. Okay, my favorite food, let's try pizza. It says mine too. Awesome, that's working. Now, if I type something else, so I type like 4, it just tells me I'm not a teenager or an adult because we don't have anything else happening inside of this if statement, or this else over here, okay? Now that's really cool, and that allows us to do some neat things. And you can continually nest, and this is called nesting, putting a statement inside of another statement. You can continually do that as much as you want. So I just wanted to show that to you because a lot of people think that that's not possible, or they don't understand that you're able to do that because they haven't been shown that, right? So again, if I want to ask another question, I could do that inside of here, and I could just keep going. What is an array? Well, an array is a collection, pretty much, of elements that is a set size. So rather than having like a variable equal to 1, you'd have an array, and it would have a bunch of different values in there that you can index at certain points. And you'll see when I start talking about them here if you're a little bit confused. But how to create an array is to first, you have to declare the type that you want your array to be. So all the values in the array, at least for right now, have to be the same type. So in this case, I'm going to create an integer array, and to declare that this is going to be an array, you simply do these little square brackets. You say int square brackets, the name of your array, in this case, I'm going to say new ARR, standing for array, is equal to, and then in this case, you're going to say new int square brackets, and inside of this square brackets, you have to define how many elements or how long your array is going to be. In this case, I'm just going to say 5, okay? So you can see that's fine, not getting any issues here just because we're not using new AR. But yeah, this is the syntax. So whatever type you want it to be, you type the type. So if I want it to be string, I do string. And then this obviously would have to be the same, string, like that, okay? Square brackets, name of your array, equals new, and then the type, square brackets, how long you want the array to be. Now there's another way to declare this, I'll show you in a second, but this is like a set length. Like you can't change this length. So you have to make sure that when you're declaring your arrays, you know how many elements you want to have. Because you can't, if you make an array length 0, then there's no point in using it. You can't add anything past like that length, okay? And what it's going to do is it's going to by default set all of these elements to like null. So they have no value, but they exist. Like they're there, they just aren't holding anything right now, okay? The way you can kind of think of it is you're initializing like 5 containers that are all gonna hold something, but they're not yet holding anything. I guess it's a good way to visualize. So we're gonna keep the string array for now. I'm gonna show you how we can add things to array, and change values and print them out and see what that looks like, okay? So the way that you index things in an array is going to look like these curly braces, okay? So I'm just going to type some stuff out and just follow with me, right? So in my string array, I want to have hello, I need double quotes, hi, Tim, maybe I should have done less values, Bill, and Joe, okay? Now these are the 5 values in my string array. Don't type this out with me, this is just showing you an example. Now, the way that we start counting in computers, or actually, let's first say this. Every element in our array is going to have an index, okay? And the index is going to be a number that represents its position. So in this case, you'd say, like, this is position 1, this is position 2, and this would be position 5. Now, if I were to ask for position 1, it would give me hello. But the thing is, that seems logical, but in computers, we actually start counting at 0. Meaning that position 1, which I'm saying is hello, is actually going to be position 0. And that means that whatever the length of my array is, so in this case 5, the last position in my array is going to be the length minus 1. So in this case 4. So Joe would be position 4. And these are known as indexes. So like index 0 is hello, index 1 is hi, index 2 is Tim. And this allows us to really easily grab different elements without having to know their value. We just know the position of them in the array. Okay, so 0, 1, 2, 3, 4. That's how we count in computers, okay? So how can we actually access these different elements? Well, I'm going to create a variable. I'm just going to say string x equals, and in this case, I want to get like value 2 in my array. So first of all, I haven't actually added anything to my array, but we'll do that in a second. But how I would do that is I would type like new AR, and then I put square brackets, and then in here I put the position. So position, so I wanted to get hello. I think that was the first or second position. We'll see. Anyways, I would type 1. And what this would give me is the second value in my array. Because remember, we start counting at 0. So the first value would be 0. And the last value would be 4. Now, maybe this is going to look a little easier once I start adding things into my array. So the way that we can actually add things into the array is, well, we've declared an array and we said it has length 5. Which means that these elements already exist, or there's buckets that are just not holding anything. So what we have to do is we have to say new AR 0 is equal to, and in this case, let's give it a value. So let's say hello, okay? Put our semicolon, there we go. We've just set position 0, index 0, whatever, to hello, okay? So now if I copy this a few times, I can set the values of all the elements in my array. So it is 0, 1, 2, and 3, and here I can just change these. So I'll say hi, I'll say Tim, I will say Bill, and we can add one more, but we don't have to. So if we let's just add one more for the sake of it. And new AR4 is equal to what do you call it? Joe. Oh, I don't know why it's doing that for me. Okay, Joe, like that. All right, so if I say string x equals new AR4, then that's going to be equal to Joe. So to print this out to the screen now, I can do system.out.println, and in this case I will say x, and let's see what we get. We get Joe, right? Because we added all of these into the array. Now if I just comment this out by doing that, let's see what happens when we do new AR4. Let's see what we get. We get null. Now that's because, remember what I said, when we initialize this array, we set it of a length of 5, and we say, okay, these are our containers. We've got 5 containers, 5 buckets. They're going to hold values. We don't know what the values are yet. All right. So if we haven't set a value for the 4th index or the 4th position, well, we don't know what it is. So we're just going to return null, meaning nothing is there right now. Okay. So yeah. So that's how you add things into an array. Now I'm going to create another array and show you a kind of an easier way to do this if you're just going to like statically type in numbers, okay? So I'm going to say int, this time we're going to do an int array just to save me from doing all these quotation marks. I'm going to say int, let's say nums is equal to new int square brackets, or actually we don't need that because we're going to do the other way. We're just going to put 2 curly braces, and in here we're going to type out our array. So in this case, this is now my number array. So I put it in curly braces, and I have an array of 2, 3, 54, 6, and 6. Now again, just to recap, 2 would be at index 0, 3 would be at index 1, okay? Because that's the way we start counting. And now, if I wanted to, instead of having x equal to new ARR, I'm going to say nums 4, which should be 6, right? And what's our error here? Change, this has to be an int, my bad. Int x equals nums 4. We print this out, you can see we get the value 6. So that's another way to create an array if you're just going to be like typing in all of the numbers like that, okay? And obviously you can create arrays of different types. So like int, we could do string, we do float, we could do double. So you say like a double array of nums2 is equal to, and then in here you do like 2.0, 3.0. There you go. We now have a, wow, really? I forgot that. Okay, well, you need that, but that works. Okay, we now have a double array. At index 0, we have 2.0. At index 1, we have 3.0. And yeah, so arrays can get fairly complicated. They're not really the best thing to be using for a lot of example cases, but for right now, we have to understand them. In later videos, I'm going to be talking about collections, which are going to allow us to do some cooler things rather than like indexing elements like this. There's some cool methods that we can use on those. But for now, I would just want to make sure that we do understand arrays, okay? So in this video, I'm going to be talking about for loops. Now, for loops are a fundamental aspect of every programming language, and they're very important to understand. And I can almost guarantee you that any program you write will use multiple for loops. So pretty much what a for loop is, it allows us to kind of automate a task, do something a set amount of times. And typically when you use a for loop, you're using that because you know how many times you want to do something, or like a condition is going to tell you how many times to do something, as opposed to what we're going to talk about in future videos, which is a while loop. Well, you're not really sure how long it's going to go for, so you do something based on a condition, but we'll talk about that when we get to it. So let's start and just do an example of what a for loop can really like solve for us, for example, okay? So say this is a pretty simple example, and you guys will see in a second, but I create an integer, let's see, int x equals 0, and say that I want to add 1, and then I want to add 2 to it, and then I want to add 3 to it, and 4, and 5, and 6, and like an infinite amount of times I want to add to that variable. Well, we could do like x plus equals 1, we could do x plus equals 2, like, and keep going and adding things to x, and we could just keep copying and pasting this down our program. But obviously that's terribly inefficient in terms of a typing standpoint. And what if we wanted to change this? What if every time we run the program, we want to ask the user how many times they want to add like a pattern like this to x? Well, then we would have to constantly keep changing the numbers here, right? So this is where for loop can kind of come in handy. So the syntax for for loop, I'm just going to type it out, and then we will talk about exactly what it does. So it has these brackets here, and in here we're going to put 3 things typically, okay? So what you're going to do is you're going to first start off by declaring a variable. So in this case, I'm going to say int x is equal to 0, okay? Now this can be called whatever you want. Typically people call it I like to use x, but you know what? Let's just use I. And then what you're going to do for this next, so you're going to put a semicolon, and then the next thing you're going to do is you're going to set a condition. So I'm just going to do this and then talk about it because it's hard to kind of do them step by step because they all work together. Less than equal to 10 and I plus plus. Okay, so what I've just done here actually is I've first started by declaring a variable I, it's equal to 0, and then I've said we're going to do this while I is less than or equal to 10, and we're going to add 1 to I. So pretty much the way this works is every time we execute what's in these little square brackets here, I is going to have 1 added to it. So this is what's known as the increment, and this comes at the end of your for loop. So this is what you're adding to the variable I, which you're declaring here, every time you run the loop. Now this here is your condition, and this is going to state how many times the loop is going to run. So in our case, we're going to run the loop while I is less than or equal to the value 10. Meaning we're going to start at the value 0 because I equals 0. We're going to run this loop. Then we're going to come back up here. We're going to say, okay, what are we doing? We're adding 1 to I. Then we're going to check this condition. So I is not equal to 1. We're going to say, well, is 1 less than or equal to 10? No, it's not. And then we're going to loop through, and we're going to continue looping through until eventually we get to the point where we add to I, it's equal to 11. 11, well, that's greater than 10. So we break out of this loop. And you guys will see when I start printing stuff to the screen exactly how this works, but I hope that was a decent explanation of the way to do this. So what I'm going to do is I'm just going to print I here, and I'm going to tell you right now what's going to happen, right? So we're starting I at 0. So the first loop here, we're going to come through I is equal to 0. We're going to print 0. Next loop, we come up, we add 1 to I, check the condition. We're okay. We can keep going. We're at 1. And we're going to print from 0 to 10. So watch when I run here, we get 0 all the way up to 10. Okay, that's how the for loop works. So we execute whatever's in between these little curly braces 10 times, or 11 times in this case, because 0 to 10 is 11. Right? Now we can change this increment, we can change this condition. There's a lot of things that we can do in this for loop. So here we say for int I equals 0, I could do for int I equals 5, and I can start at the value 5. And now we're going to start, and we're going to go from 5 to 10, looping 1, 2, 3, 4, 5, 6 times, right? We're printing 6 different values, okay? So that's, like, you can do that. If I try to do something like I equals 11, well, watch what happens. Nothing prints to the screen. And that's because 11, well, that's greater than or equal to 10, so the loop doesn't even run one time, right? So let's go back and let's start at 0, and now let's show what we can do in terms of incrementing. So to increment here, we can do I plus equals, and then any value you want. So in this case, if I do 5, we're going to start at 0, we're going to add 5, we're going to add 5 again, so we get 0, 5, and 10. And you can change this to whatever value that you want. Okay, same thing here with the condition. These can also be variables. I feel like I don't need to tell you that, but if I do something like int x equals 5, then I could do I plus equals x, right? And we can add that integer to it. We could add x as the bound here, so less than or equal to. This could be greater than. This could be greater than or equal to. So I'm just going to quickly go over one thing that a lot of people get confused with for loops. And it's when we're going to stop and when we're going to start. So when we say less than or equal to 10, this means we're going to start at this value, and now assuming we're adding 1, okay, we are going to stop but include 10, meaning that I will hit the value 10, we will print 10 to the screen. Now if I remove this equal sign, this is only going to happen while I is less than 10, which means that if I is 10, well 10 is not less than 10, so we are not going to print 10. So if I run this, you can see we only get up to the value 9. Now, the reason I'm talking about this is because what we typically want to do with loops is we want to loop through something or look at some data, and typically that data is in the form of an array. So now, and this is why I talked about arrays before, I'm going to create an array, so an integer array, it's called ARR, is equal to, and let's just give it some values here, so like 1, 5, 7, 3, 4, 5, okay? This is going to be our integer array. Now, what do I want to do how am I going to do this if I want to look through my array and look at these values and maybe check if a value is equal to 7 or value is equal to 5 or something like that? Well, the way that I can do this, and this is like a dynamic way to do it, is I could count the length of the array. I could say 1, 2, 3, 4, 5, 6. Okay, 6 elements. So I would put I is less than 6 here. But a more useful way to do this is to just get the length of the array. And the way that I can do that is just to do arr.length. Or I actually don't need these brackets, sorry. So we'll just do this. In this way, say the user had typed in a bunch of elements, we had put them in an array. We don't know how many elements they type in per se, so we're going to use this length so that we can change this loop, and this loop will never crash. It will always work because we're just simply getting the length of the array. Now, if I were to do equal here, I hope you guys realize this would cause us an issue. And that's because we have 6 elements in the array, right? But it's going to allow us to get I to the value 6 because that's the length of the array. Now, what happens if I try to do this, ARR of 6? Well, we should know from the last video that that will actually crash our program. And that's because when we start at 0, and our last element in the array is actually going to be index 5, right? Because we go 0 all the way to the length -1, which is 5. So array 6 does not actually exist. So what I'm going to do now is I'm just going to write a little program inside this for loop, and I'm just going to say if the value is equal to 5, we're going to print it out. So how do I do this? I'm going to say if ARR at index I is equal to the value 5, then we're simply going to do a system.out.println. I just realized there's a comma there. All right. Semicolon, and we're simply going to print the value. So in this case, we could print ARRI, which we know is going to be 5, or we could just type 5 because we know that it's there. So in this case, let's just do found a 5 exclamation point. Okay, that's what we'll print to the screen. So again, the reason this is going to work is because we're looping through starting at 0 and going to, but not including the length of the array. Make sure you remove that equal sign, otherwise you're going to get a crash, okay? So that way, we're going to look at every single element in this array, we're going to check its value, and then if we find a 5, we're going to print it. So let's see if this works. Found a 5 and found a 5. Now, if I wanted to be more precise and say like where I found this 5, I could say found a 5 at index, and we'll just put a plus sign, and then we can put I. And what this is going to do is it's actually just going to automatically convert this into a string for us and print it out with this index. So we're going to put a space here just so they don't get smushed together. But it says found a 5 at index 1, found a 5 at index 5. And we know this is true. Index 1 is here, index 5 is here. And that's a really simple way that we can loop through a list and look for a certain value, okay? I'm going to be showing you a different kind of for loop, which is known as a for each loop. And this is going to allow us to loop through the elements of a list or a collection data type and do something with those elements. I'm also going to be showing you ways that we can break out of the loop at certain points. So if the condition is not met, or like we just want to get out of the loop, the way that we can do that. And I'm going to be showing you some common examples of where we use loops. So let's go ahead and get started. So you can see that I have two arrays here. One's named names and one is named AR. I just added this names one. It's just a blank array for right now, okay? So what I first want to do is, in the last video, I looped through this array. And the way I did that was by having a variable I. We waited until it was, greater than the length of the list. And then once it was, we simply broke out of that loop, right? Okay, so an easier way to do this is to do something like this. So we're going to have the same exact syntax, except in these brackets, something is going to be different, okay? What I'm going to do if I want to loop through every element in this list is I can do something like this. I can say for element colon ARR. Now what this is actually going to do, I have to do this, sorry, string element, or I can't say string because that's not the right type, int element in our array. So what I'm doing now is I'm saying that every time we loop through this loop, right, what we're going to do is we're going to declare a new variable called element, and it is going to be equal to the next element in our array. So in this case, when we first loop, element is going to be equal to 1, and then element's going to be equal to 5, and then it's going to be equal to 7, and then 3, and then 4, and then 5. And this is a way easier way if I wanted to like print out the element or look at certain elements to do so, rather than having to have like a counter variable I and then index all of the different elements, especially if we don't know the length of the array or we don't want to do dot length, because this is automatically going to go from start to end, okay? Now, I'm going to show you because obviously we need an example to really understand this, but the first example I typically like to do is just printing out all of these elements to show you that it is indeed working. So in this case, we'll just say element, okay, and we'll just print this to the screen and see what we get. So in this case, you see we get 1, 5, 7, 3, 4, 5. So right, starting at the beginning, going to the end. The way this works with the colon is, again, we're just grabbing the elements in order and we're using those as a variable element. Now, a lot of times what you want to do with this is you want to be checking the element, but you also want the index as well. So you want the element and you want the index. Now we could use what we used in the last video where we just have a counter variable, and that way we have the index and the element because we can do like ARR of 1, like all that, okay, or of I. But a way that people typically do this is with like an outside counter variable that you increment yourself. So I'll show you how this works. So what we're going to start off by doing is just creating a variable that's called int count equals 0. And then within this loop, we're going to increment count ourselves. So now, every time that we run the loop, we're adding 1 to count, so that count is keeping track of the index of the element. So if I print out the element plus, we'll do this, I guess I can't do that, plus a space, plus our count, you can see that this is keeping track of the index. So what's happening here, it says 1 is at index 0, 5 index 1, and it keeps track of all of these different indexes for us, and that's a really easy way to do that. I just wanted to show, it doesn't really make sense for this example case, but I just wanted to show you because there will be situations where you want both the element and the index, and it's easier to get the element just by doing this with this colon, okay? So again, when you're doing a for each, this is what this is known as, because it's going through for each element in the array, we are doing something, okay? All right, so the next thing that I want to do is I want to show you how we can populate an array using a for loop. So right here, for example, we have a a new string array that's empty, right? Like all these elements are null, and we want to populate them. So the way that we would go about doing this, and this is a common example of what you want to do, that's why I'm showing you this, is we create a variable. We're going to say again int I equals 0. We'll say, well, I is less than, and then names dot length, right? And then we'll do a semicolon, and we'll simply add 1 to I. So this is the exact same thing as we've done before, but I'm just going to show you how we can actually add the elements, because this is a really common use case. So what I'm going to do here is I'm actually going to use the scanner to get a new variable, or to get like a name from the user. So I'm just going to say scanner sc equals new scanner, and then we need system.in. Okay, and I actually think I should probably not declare this every loop, but put it up here because we're just going to use the scanner, right? So we'll say string of input equals sc dot next line like this. And this way, every time we run the loop, we are going to get input from the user. And you know what? Let's also just print out here system.out println, and just tell the user we want, actually we'll just do print, not ln. We'll say input like this, so that way they know what to type in. Okay, so input, we're getting input, and now what I'm going to do is I'm going to add the user's input into our array. So how can I do this? Well, this is really easy. I can just do names I is equal to input, right? So we're just declaring that whatever index we are in the loop right now, so whatever value of I, well, that value in the list, or sorry, the list, I keep calling it list, it's an array, I'm just used to Python, is going to be equal to whatever we typed in. And then if we want to print out the entire array, what we can do is we'll use another for loop, so we'll just say for, and then this time it's going to be a for each loop, right? So we'll say for n, this just stand for name, string n and names, okay? Then we will simply just do system.out.println, and we will print every value of n. Okay, so that's two good examples. Let's run this and just make sure everything's working. So we run this input. I'm just going to type hello. Oh, I guess it wanted names, didn't it? Tim, Bob, Joe, Bill, and then there we go. So we ran that 5 times, and we get hello, Tim, Bob, Joe, and Bill. Awesome, there we go. So that gives us all the values that we need, okay? Okay, so now what I want to show you guys is how we can break out of the loop. So if we're in the loop and we're going through and we're doing operations and we've not yet met the condition where, or like, so the loop is going to keep going, like I is not greater than whatever value or whatnot, okay? Then we want to break out of it. How can we do that? So how can we just get out of it in the middle of looping? Well, there is this magical little keyword called break. And what this does is whenever this is encountered inside of a loop, it simply breaks out of the loop. So in this case, what would happen is, since I have break at the end, we would do these first 3 lines, and then we just break. And this would only happen one time, no matter what any of this stuff said, this loop would only happen once. Now, I'm going to show you just down here in this loop how we can break out based on like a certain condition. So for example, say we encounter the word n, or what do you call it? The word Tim. What am I saying? N? I was just reading that. If we encounter like the word Tim while we're reading through the list of names, then we just want to break out. Like we don't want to print any more names anymore. We just want to break out. So the way that I can do this is now I can say, well, we're gonna print Tim, but we'll break after Tim. Okay. So what I'm gonna do in a dual if statement, I'm gonna say if n equals or not equals dot equals. Okay. And in this case, we'll just simply put Tim in here. Then what we are going to do is we're going to break. And in this case, now, whenever we encounter Tim, we are simply breaking out of the loop, and that means we will not print the rest of the names. So if I run this, just drag this console up here, and we run, and we say hello, and we say name, and then we say Tim, and I'll just show you this Tim and Tim, and I run this here, you see we get hello, name, and Tim, and these other 2 Tims do not print. And again, that's because once we hit Tim and n is equal to Tim, we simply break. Okay, and we get out of the loop. And that's like a really easy way to just break out of the loop. And this is going to work for while loops that we do in, the next video. Now, typically break is not something you want to be using a lot. Like, you only use this if you really have to. It's better to just make these conditions work the way they should, and have the loop run like as many times as it needs to run, you know what I mean? So just try not to use this too much, but I mean, there's nothing really wrong with using it. People just are frown upon it in the programming world using the word break, okay? We're going to be talking about while loops. Now, while loops are very similar to for loops. Anything you do with the for loop, you can indeed do with the while loop. That being said, they do have different use cases in terms of where they're most useful, but just remember, anything you do with the for loop, you can do with the while loop. Anything you do with the while loop, you can do with the for loop. They're completely interchangeable, and if you only had one of them in programming, you'd still be able to do everything. It just might be not as, I don't know, nice to code, if that's the right word for it. Or elegant is probably the better word. So a while loop is going to work when you typically don't know how many times you want to loop through something. So it's kind of like a question, like, you know, it's going to be based on this condition, but you're not really sure. Like, if a for loop is more like, you know, you're going to do it a set amount of times, a while loop is, it could change based on the program, based on user input, okay, something like that. So what we're going to do here with this while loop is I'm just going to set one up, and then we'll just talk about exactly what it does. So in this case, what I want my while loop to do is I want it to just continually keep asking the user for input until they give me like a certain word, or like one of two words. Okay, so in this case, what I'm going to do, I'm just going to say, let's see here, maybe just get an int, this will be faster. Say int x equals sc dot next int, like this. Okay, and what I'm going to do is I'm just going to keep looping through until they type the number 10. Okay, so while I can do this is you just type the keyword while in here, and then in these brackets is going to be your condition. Now, this is why I focus so much about conditions in the first two videos, because they go a lot with if loops, while loops, for loops. So while this condition is true, then we're going to run the loop. So in this case, I'm going to say while x does not equal 10. Okay, yeah, exactly. Okay, that's true. So if they type in 10, then it will not continue to do this. Otherwise, we will continue to do this. So that means I'm also going to have to get the int in here, because every time that we run this loop, we want to continue getting x. So in this case, we already have x defined. We just do x. And what I'm going to do is, if they don't type in 10, I'm simply going to tell them, like, type in 10. So we'll just say dot println. In this case, I will just say type 10 dot dot dot. And you know what, we're also just going to print out, because I like to do this, we'll just do system.out .println, and in this case we'll say type a number, just the user knows what we're looking for. Okay, and that means we're also going to have to print this here, and it should just be print, not println. My apologies. Okay, so again, the way this is going to work is we're just going to continually keep looping through this until eventually the user types in 10. In that case, we will break it. Okay, and we will not loop through this anymore. So let's run this. Type a number. Let's type 4. It says type 10 dot dot dot. Type a number. Type 5. Doesn't work. Type 10. There we go. And we broke out of the loop, and it no longer asked us for that number. Now, these are actually really simple. It just, while this condition is true, do everything that's in here. And that's all you really have to know about while loops. Now, again, like, we can, what I was saying, we can do everything that, with for loops, with while loops, because we can also count in while loops as well. So just like I did before, I could do something like int count equals 0. And then every time we run this loop, we could just say count plus plus. And then maybe at the end of our loop, we wanted to do, like, tell them how many times they messed up. Okay, what am I saying? Print system.out .println. And in this case, we'll just say you tried, you tried, and then plus count plus times. Okay, make sure we add a little space here. All right, so now if we run this, and we'll say like 1, 2, 3, and 10. You tried 3 times until, like, eventually you got it. Okay, so that's like a really simple way to do stuff with while loops. Now, you guys might notice that this code here, like this, these lines are repeated up here. So I have this int x and this type of number So how can I do this without repeating those lines? Because I don't want to have to type, like, what if I wanted to ask a ton of different questions and then do the while loop? Well, I don't want to have the same section of code appearing multiple times. So there's actually something called a do while loop. So what I'm going to do is I'm just going to erase all this, and I'm going to set up this do while loop. And it's pretty much what it says. We're going to do everything while this is true. And you'll see how it works in just a second. So I'm going to type the keyword do, brackets, and now everything in this brackets is what is going to happen while the condition that I put down here is true. So the condition here is going to be the same. While x does not equal 10. We're going to do everything in here. So now you can see this is working fine. There's no issues. And what I'm going to simply do is I'm going to take this these two lines here. I don't need that scanner because we're not going to redefine that every time. And I'm going to paste them in here. And what this is going to allow us to do now is x does not equal 0. Create local, gosh, okay. Let's just do this. Int x and then x. Okay, perfect. There we go. So sorry, that was just a quick issue. But what this is going to allow us to do is we're automatically going to do this once. No matter what, this is going to happen once because we're going to do this. And at this point, x is not equal to 10. So we're automatically going to do this once, which means we don't have to have it up top and then down below. So we do that. And then we check the condition. If it's true, we'll do it again. Or yeah. And if it's not, then we will break. So we can do this. We'll say type a number. Let's do 4. Let's do 5. Let's do -0. Is that a number? Yeah. Okay. And 10. And there we go. We break out of the loop and everything is working fine. And that is pretty much it for while loops. Again, if you wanted to set one up to look like a for loop, then you'd literally just have to create a variable. In this case, say like int x equals 0. You can set up a while loop. So you say while and you say x is less than or equal to 10. And then in here, you just say x plus equals 1 or plus equals 2 or whatever value you want to add to it. And then you can just do what you would do in the for loop underneath your increment. Or you could put the increment, typically you'd put it at the end. So at the end of the loop, you're adding 1 and then you're checking, okay? Now in this video, I'm going to be talking about sets and lists. Now, sets and lists are from something known as the collection interface from Java. I believe that's what it's called. Someone correct me if that's wrong, but I think that's the name. And they are fairly complicated. Now, I'm just going to talk about really like the basics of them. There's a lot more to do with sets and lists. I know I'm probably going to get some comment from some guy who says, wow, you didn't talk about a lot of this. But I can't explain all of it to you guys right now because it's very difficult to understand if you don't know a lot about data structures, which in our case, we don't. So I'm just going to talk about what a list is, what a set is quickly, and a very basic standard implementation of them. Now, the reason I'm doing this is because whenever you're programming stuff, like a lot of Java tutorials you watch probably won't talk about these because they're really complicated, but you're going to need them to do certain things. So for example, with an array, what I talked about before, how you could you had to set the size of the array, like you had to know how many elements you wanted. You don't need to do that with a set or with a list. And that's the main advantage of it, because a lot of times we're going to be adding things into per se a list or a set, and we don't know how many things we're going to be adding, so we can't define like an array of that length, if that makes sense to us. So let's actually just get started. We're going to talk about sets first, and then we'll move into lists. So I'm just going to create a set, and I'm just going to type it out and then kind of explain exactly what I'm doing. I'm just going to call this set t equal to new. That's what we need. New hash set and integer. Okay. So this already probably looks confusing, and if you're typing this out with me, you're getting these red lines. Now, what we should do to get rid of these red lines is we just have to hover over them and click import set by like clicking on whatever it says there. If you don't have, if you're not using this IDE, just literally type import java.util.set. And for hash set, same thing. We're just going to click on it and import it, just because this isn't like built into main the Java functionality. All right. So we have a set. Now, what is a set? How do we create it? Well, a set is a collection of unordered elements that are unique, meaning that a set cannot contain the same element twice, and it doesn't know where that element exists. So you can kind of think of a set as just like a big bubble, and you kind of just throw things into it, and it doesn't really know where they are. It just knows that they exist there. Now, you also have to understand that it can only be unique things. So for example, I've created this integer set, and this is the way that you do it. So you type the keyword set in these little like greater than sign, less than sign, whatever you want to call it, tags. If you're talking HTML, you type integer, and I have the name t, and I'm setting that equal to new hash set. Now, you don't have to understand what a hash set is, just know that it's like the standard implementation of a set. And then same thing, the type, so integer, and then these brackets here. Now, inside of these brackets, if you had another set you had created, like say I created a set called like W, I could put W in here, and assuming it had any elements in it, this set would get all of the elements from W and start with that, and then you could add things into it and whatnot, okay? So to add things to a set, I'm just going to do this. We'll go through and see how it works, all right? You simply type .add. So I'm going to say t.add. In this case, I'm going to add 5. And we'll just copy this, and we'll add like a few different numbers into our set. So in this case, I'll add 7, and we'll add 5 again, and then we'll add 9, okay? Now what I'm going to do is I'm just going to print this set out to show you what it looks like. Now remember I said unordered collection of unique elements, okay? So let's print this out. And you can see that we get 5, 7, and 9. And notice that this add right here actually didn't do anything. And that's because since we already have a 5 in our set, when we try to add another 5 to it, since it already exists, it doesn't care, and it just doesn't add it. All right, now I'm going to add another element. In this case, let's add like negative 0, -8, all right, as our element. And you can see that we don't have any specific order. Now, see when I printed this, like I had added 5, 7, 9, and -8. So you think that should be the order that we get it, or it should come in some sorted order or something like that. That doesn't happen with a hash set, okay, a standard hash set. And that's just because, again, we're just a bubble. We just know that things exist. We don't care where they exist or how many times they exist. We just care if they exist. Now, to see if something exists in a set, and this is typically something you want to do, like this is a main operation, checking if something exists. That's why you use a set. You can type t.contains, or like your set name.contains, and then any element in here that you want. So in this case, I can do like if 5 is contained in the set, and it's going to be able to tell me that really fast. Now, I can't really explain to you why sets are so fast, but just know that whenever you're looking for something in a set, you can do that very quickly, like very fast, like in constant time. It doesn't matter how big the set is. The set could be 2 million elements, or it could be 5 elements. It'll take you the same amount of time to look if something exists in the set. Okay, and same thing with adding and removing things from the set. That happens almost instantly, as opposed to with arrays. The larger the array gets, the longer it's going to take us to look through and find certain elements. Okay, just we have to understand that. So what I'm going to do is create a variable. I'm just going to call it Boolean x is equal to this, and what I'm going to do is I'm simply just going to print x now to see if that is contained. And in this case, yes, it is. 5 is contained. Again, if I do something like 0, then obviously we get false. It's not in there. To remove something, we can type t.remove or set name.remove, and then whatever the element is that we want to remove. So in this case, if I wanted to remove like 9 from my set, I would do that. And then if I print my set, so in this case t, we just get 5, 7, -8 because we removed 9. Those are kind of like the standard operations. I'm trying to think if there's any other ones. Okay, so there's one more, or there's a few more, but I don't know which ones are important. You can clear an entire set by just doing .clear. So just simply remove everything from it, like that. To see if a set is empty, you can do .isEmpty, and this will literally just tell you if it's empty or not. To get the length of the set, you can do .size, and this will tell you how many elements. So in this case, if I do size, change this to an int, and just print x here, then we get a size of 3. So like again, if we had nothing in there, the size would be 0. So is empty and that are kind of like similar in the sense that you can just check by the size. And yeah, so that's a hash set. A hash set is like the standard set, and that's the way that it works, the way I explained it to you. Now they also have a tree set, and we also have a linked hash set. Now, whenever you use these things, they're going to pop up here. I'm not really going to talk about what these do too much. I'm just going to kind of show you the way a tree set works. Now, a tree set is similar to a set in the sense that you can only have or a hash set, sorry, that you can only have unique elements. But these are actually ordered, and they're ordered in a tree data structure. You don't have to understand what this means. Just know that it's like it shows up ordered. What's our problem here? Just want to read this error. Tree set cannot be resolved to a type. Interesting. Okay, tree set. Well, let's just try this. That still worked. Okay, so anyways, I don't know why it was showing me an error, but tree set is going to actually give us an order. So if I type T like this, you can see that we actually have an order for the set now. So -8, 5, and 7. Now, like arrays, like we can't just index the set and we can't just say like T0. Like that doesn't work doing that like we were able to do with arrays. But when we print it out or when we look through the set, it maintains this order in like a tree functionality that I can't really explain to you. Now, linked hash sets are this. So linked hash set, again, we're gonna have to import this up there. It's linked hash set, and this is similar to a basic set. It's just faster on certain operations. So I'm not like, I don't really want to talk about them too much because I feel like I'm already confusing you guys, but just understand if maybe you know a bit about like operations and speed and time complexity. You have a linked hash set, a regular hash set, and a tree hash set or tree set or whatever I typed. Okay. All right. So that's enough for sets. Don't worry if this is a bit confusing. Like we're not going to be using these too much. I just want to show you because I feel like you guys are going to need to do this for some of your projects or whatnot if you're learning this for a reason. Now we also have lists. Now lists, these are easier to understand, don't worry. But there is, again, 2 types. So to create a list, what we're going to do is we're actually going to type array list. We're going to give it a type. In this case, I'm just going to give it an integer type. And notice how I'm not typing int, I'm typing integer. Just that's important that we need to use integer here instead of int, okay? So array list integer, I'm going to call this one T again, equals new array list. And we'll type integer. And we'll put brackets, and there we go. Now we're gonna have to import this, so import array list up there, and we now have a list. And what a list allows us to do is you can almost think of it as the exact same thing as an array, except it's a bit slower, and it can change sizes. So we can add things to it, we can remove things from it, and if we get to like the end of the array, or the end of the list, sorry, we can just add another element into it. It doesn't matter. So we can have like a dynamically sized array. These have pretty much identical properties to the set. So to add things, you can do t.add, and you can add like in any element you want. So you add like 1, right? Okay, that works fine. To remove things, t.remove. Now to index things, because just like an array, we can actually index things with a list because this is going to care about the position. It's not going to just care that it exists like a set. What we can do is we can do t.get. And then we can give an index, right? So it's showing, it's literally saying index right here. So I do .index0, then that would give me 1, right? Because 1 is added in there. Now to like put something or to set something at a certain index, what you do this is t.set, and you type the index and the element. So I wanted to set index 1 per se to be equal to like 5, then that's the way I would do it. Index 1 is 5, okay? We print out T here just to show you what it looks like. 1 sec. Okay, sorry, but we can't do that. We have to do T. We have to add something in. So to set something like this, sorry, you have to actually have something added at that index. I forgot I didn't add that. So I'm just gonna add 2. So what I'm doing now essentially is what this set actually does is you have to have something already existing at that index, and this is going to change that index for you. So this is to change an already existing index, and before I was trying to set 1 when we didn't have that in, so that was my mistake. But anyways, there we go. So now that works. We've changed 2 to equal to 5, and 2 is at position 1, right? So that's the way that works. I've just got a thing up here. I'm just going to read through a few of these. Yeah, okay, so that's the basic ones. Again, we have .size, so t.size. We can do t.empty or is empty, and this is actually a really useful one. It's called sublist, and what this allows us to do is get from certain indexes. So t.sublist, let's see, add argument. Yeah, so we just need int. So this is going to allow us to get within a certain range. So say I add like these a bunch of times, Okay, so we have 6 elements now. What I want to do is I want to get from like index 1 to index 3, and I want to print that to the screen. So let's just take this and put this here instead. So let's get rid of T, get rid of this semicolon, and print out and see what we get. So what we get here now is 5 and 1, because although our list actually has, what do you call it, like 6 elements in it from here, we can just get the elements from 1 to 3, not including 3. So if I type like 1 to 4, then you should see we get 1 more element in here. We get 5, 1, and 2, because that's from index 1 to index 4, but not including index 4. That's what we're grabbing, and we're getting all those elements in the sublist like that. Now this is array list. We also have linked list. Again, this is another data structure that I can't really explain to you. Just understand that it is faster at certain operations than an array list. So for any of you that understand the difference between this, you have linked list and array list. And you guys, I recommend you to play with those and figure them out on yourself. Anyways, we're coming up on about 15 minutes now almost, and that's pretty much all I wanted to talk about with sets and lists. Now I know this video might have been a bit confusing. There's a lot of stuff that I wasn't able to explain to you guys, but just understand that if you're trying to do something and you don't know how long you want something to be, like a list or an array, you don't know how long you want it to be, it's a different amount of elements, like you don't know, you would just use an array list the way that I showed that to you before. So array list like that, because then you can add things, you can get things, you can set things, and you don't have to worry about like having a designated length. The reason you use a set is when you don't care how many times something exists or where it exists, you just care if it exists. And the reason a set is better is because it's simpler and it's a lot faster to do operations on in terms of like a computer efficiency standpoint. That's when you would use a set. I'm going to be talking about hash maps, or like Java maps. The reason I say it like that is because there's a few different implementations of maps, similar as to how there was different implementations of lists and like array lists and all that stuff. So maps, if you're coming from Python like me, you can think of them as dictionaries. And I'm going to be talking about 3 different types of maps. So a hash map, a tree map, and what was the last one? I got it written down here. Linked hash map, sorry, just forgot about that one. So pretty much a map is known as a key value pair. In any other languages, they're typically called dictionaries or hash tables or hash maps or whatnot, okay? So to create a map, and I'm just going to do this and then we'll talk about exactly what it does. I'm just going to create a map M. It's going to equal to new hash map like this, okay? And this is your simple syntax. Now you have to import this, so I'm just going to import java.util. So just by clicking on it, and we have to import map as well. So we'll import the map there. So you see it's all coming up now for us. Okay, so now that we have that, I want to talk about exactly what a map is. Now a map, like I said, is a key value pair, meaning that it's similar to like a list and an array in the sense that you can index things, but instead of indexing them by numbers, you index them by keys. Now keys can be anything that you want. A key could be a string, a key could be an array. Actually, I'm not sure if it could be an array, but it could be a string, it could be a number, it could be a char, it could be a float, like pretty much whatever you want can be the key, and that key links us to a value. So the easiest way to kind of demonstrate this is just to do it and then to talk about what's really happening. So to put a new value into a hash map or into a map, what you do is you have to specify a key and a value. So you type whatever the name of your map is, in this case m.put, and then you need to put a key and a value. So in this case, for my key, I'm going to type Tim, and it is going to lead to the value 5. So I type Tim, and then the value is 5. So I put that in there, and now I'll just show you what it looks like if we print this out to the screen, because I think it will give us a decent representation. What am I saying? System.out.println. Sorry guys, I'm a little tired today. And we'll print M and see what we get. So in this case, you can say we see this. So curly braces says Tim is equal to 5, meaning that if we're to index Tim, we get the value 5. Now, how do we do that? So how do we actually get a value based on a key? The way we can do this is if you put square brackets next to your map. Actually, you can't do it like that. This is Python. We have to do m dot and then get. sorry, I'm still used to the Python syntax here, guys. We type m.get, okay? And then we put the key in here. So in this case, I'm going to put Tim as my key. And, well, you should already be predicting what we're going to get out to the screen. In this case, we get the value 5. And that is because the key Tim leads us to the value 5. Now, to put another thing into our map, we can do this, right? So we do Tim, we could do like Joe. And Joe doesn't have to point to a number. It could point to another string. And that string could be like, I don't know, X, okay? And we can just do whatever we want. Like we can have the key 1 and or the key 11, and the key 11 points to 999, okay? And now if I just print M out, you'll see that we don't get any issues and that this works fine. We get Joe equals X, Tim equals 5, 11 equals 999, okay? Now this is an extremely fast data set, meaning, or data type, whatever you want to call it, meaning that everything from adding to removing to overwriting to getting happens in constant time. Now again, like I talked about in my sets video, you don't really have to understand what that means, but if you do, that's great, and just know that this does happen in constant time. Now I'm going to show I guess I'll show the tree map and the, what was the other map I talked about? Linked hash map first, and then we can kind of talk about the differences between them. So with a hash map, as opposed to the other type of maps I'm going to show you, this one does not retain an order. So all of these maps can only contain unique elements or unique keys, meaning that if I try to add another key, so I try to add 11 and I try to add this to be 998, instead of adding another key that's equal to 11, we're simply overwriting this already existing key that is 11. So in this case, you can see that we overwrite it and we get 998. You cannot have two of the same keys existing in the map, but you can have two of the same values if you'd like to, okay? So sorry, that kind of got me off track, but that was important to understand. So this hash map does not guarantee the order in which we add things in. So you can see that I added Tim in, then I added Joe, and then I added 11, and it's showing me Joe, Tim, and 11. Now this is not any kind of sorted order, because how do we sort numbers and strings and all that stuff together? It's not in the order that we added it in, so what order is it in? Well, it is in no order. And that is why this hash map is extremely fast, because it does not keep track of the order of elements when they go in. So just know that if you're trying to like look through the map, because you can iterate through maps, and I'm going to show you that in a second, it doesn't keep it in the correct order, okay? Now, the next map that we're going to talk about is the tree map, okay? Now this tree map is, well, we're going to have to import it, of course, is similar to the tree list or the tree set or whatever one I showed you in the other video, in that when we add things in, it's actually going to keep it in a sorted order. So if I run this, I'm actually curious to see what kind of sort we're going to get. Okay, so we don't get anything. So that's actually a good error to run into. Whenever we're using a tree map, the types that we add to the map have to be the same, meaning that the keys have to be the same data type. At least I'm pretty sure. So I'm just going to see if I remove this, if this is going to work for us. Yes, so in that case, we do get, in a sorted order, we get Joe, and then we get Tim, because obviously J is before T, and that's the way it's going to sort strings. So if I try to put like an A value in here, so it's even showing me key value, I'll literally just put like A is equal to B, and I guess we can't say equal, we have to say comma. What's our error? Semicolon, always forgetting those, aren't I? Okay, so we'll run this. There we go. So you see we get A first because obviously A, well, that's the first letter in the alphabet. So that's going to show up before Joe and before Tim. So that sorts the order for us. And that means that the data types for the keys that we pass in have to be the same. So we could use numbers, we could use strings, use whatever data type we want. They just have to be completely the same for that map. Now, for the other type is a linked hash map. And what this does is it's similar to a list in that it keeps the same order that you add things into it. So in this case, if I print out M, you can see we get Tim, Joe, and then A. And that's because it's actually going to maintain the order in which we added elements. So it's going to say Tim, that was the first element, so that's going to be the first thing that we show. And then Joe, that's going to be the first thing, and then second, and then A, this is going to be the third thing, because that's the order in which we added them in. And those are the only main differences, other than like the speed of which these things run at, that you have to kind of understand right now, okay? And typically, whenever you do anything, you're just going to be using a hash map. You don't really need like a linked hash map or a tree hash map or tree map, whatever it's called, for any of the stuff that we're going to be doing right now. So what I'm going to do now is I'm just going to show you a few methods, how we can kind of clear the maps, how we can like remove elements, and some useful things that you might want to do. So what we can do to get all of the key values, or to get like a certain key value, we can say, actually, I'll just show this one first. What we can actually do is there's cool things that are going to be really useful to you. And dot contains value. So this is, let's see, this method contains values not available for type map. Interesting. Match contains value object. Yeah, so we just have to put something in there. Okay. So m.contains value, and then in here we're just going to put like any value you want. So in this case, b. So what this is going to do is it is actually going to check for us if this value exists in the map. And remember, the values are all these second elements here, and they are linked up or like attached to the key. So it's going to tell us if b exists. Now we can do the same thing with keys, and the keys are more useful, and I'll show you why in a second. Contains key. And in this case for the key, I could put like contains the key 5, right? And that will give us a true or false value, similar to what we were doing with sets and lists in the last video. Okay, now the reason keys are more useful is because if I try to do something like m.get and I put the key, let's say 5, well, the key 5 does not exist. The value 5 exists, but the key 5 does not exist. So watch what happens when I run the program. m.get 5. Actually, let's just see what this is printing out to us, because I'm curious if this is going to crash for us or not. Let's see here. m.get 5. No, yeah. So this isn't going to actually crash for us if we try to get a what do you call it? A key that does not exist in the map, but it's going to return us a null value because this key does not exist in the map. That's actually interesting. I didn't know that. In Python, if you try to get a key from a map or from a dictionary and it doesn't exist, you actually get an error. So that's interesting to know. Anyways, I guess another method I could show is, let's see here, dot values. So what this is going to do is it actually just prints out all of the values in the map. So if I copy this and I simply print it down here, we get m.values, and in this case it'll just give me x, b, and 5, which are all these, and you can see it gives me that in no particular order. It's important to remember. Values, let's see if there's any other ones we can use. We can use clear. So I've just got a text document beside me because I always forget all these to show you. I always forget which ones. So m.clear, obviously this is just going to remove everything from the, what do you call it, the map. So we get an empty map. And I believe the last one is empty. And this one, like that, is simply just going to tell us if the map is empty or if it's not empty. Now, how much time are we at? 10 minutes. So I am not going to show you an example of using these maps, but if you want to think about this and maybe try programming this yourself using the maps that I just showed you, would be a good exercise. And that is, given a string or like an array of characters, count all of those characters into a map. So have a key that's equal to, let's say, the letter, and then the value for that key is equal to the how many times that letter occurs or how many times that character occurs, and try to do that by yourself. And if you're able to accomplish that, well, then you're definitely learning and you're understanding the stuff that I'm explaining. What I'm going to be doing is showing you some common problems that you're going to want to solve and how you can do that with the information I've showed you so far. So kind of bringing everything in now, mixing it all together and using all the things. And this is a really good way to kind of like apply all the knowledge that we've just learned into solving like a few common computer problems, because a lot of the time you guys learn how to do all this stuff, but you don't know how to kind of mix it all together. And that's what I'm trying to do in this video. So I'm also going to be showing you some like useful methods and some things that I may have forgotten to talk about in previous videos. So yeah, that's what this video is going to be about. So in the last video, I mentioned that a good exercise to do would be if you have like, I don't know, a word and you want to count, or like a sentence or a string, you want to count all of the letters and store them in like a hash map and have the letter as the key and the value being how many times they appear. So I figured for any of you guys that were brave enough to attempt that on yourself, I would show you a solution here quickly to doing that. And for any of you guys who didn't see that, make sure you pay attention because this is really useful. It's going to help you also to understand kind of how maps work and how you can use them. So what I'm going to do first of all is I'm just going to create a string. Let's call str is equal to, and I'll say, hello, my name is Tim, and I am cool. All right, very creative string name. Anyways, so we're gonna do that just because we're gonna count all of the letters in this string. Now, the human way to count this would be to go through and literally read like each letter and be like, okay, so I have an L, how many times does L appear? But I'm gonna show you how we do this with maps and for loops like very efficiently in computing. So what I'm gonna do is I'm gonna create a for loop. What we're gonna do is we're gonna loop through the string. And the way that we can do this is because if I try to do like for char or like X, because it's gonna be a character, right? And in str, you see we get this red line. It says we can't iterate over a string. So the way that we can do this is actually a cool method and a useful method, and it is going to convert this string into a character array for us. And the way that we can do that is by doing, I guess, a dot to char array. And this is, if I literally just print this out for you, if you want to see what it looks like, system.out.println is simply just going to put every character, so including the spaces, into a character array for us. So let's just run this. And you can see it's literally just printing this entire thing, but it's actually in an array, and this is going to allow us to loop through it. So you'll see in a second. Okay. So what I'm going to do now is every character, I'm going to see if that key already exists in the map. If it does, I'm going to get the value because that value is going to be how many times it exists. So in this case, say I'm looking for like M, it already exists in the map. I'm just going to add 1 to it and then overwrite that key with a new value. And you'll see what I mean here in a second. So I'm going to say if m dot contains key of X, then what I'm going to do is I'm going to say old, we'll say int old equals m dot get, and then the key is going to be X. And then what we're going to do is, what's the issue here? Add cast int if m, I need this. Forgetting all my brackets. Int old equals m dot get X, and X should be, interesting, 1 second. It's saying I have to cast this to an integer. Okay, let's just do this. I don't think we actually need to do this, but let's just cast it to an int. All right, anyways. And then we'll say m dot put, and for the key is going to be X because that's going to be the character, and we're going to say old plus 1. Now what this should do for us is just increment the amount, so that's going to go up by 1. Now otherwise, so if that key does not exist, what we're going to do is we're going to put into our map a new key, and the key's value is going to be 1 because we just found the first occurrence of that letter, and the key is going to be X, standing for the letter. And that should work. Now after we do that, I want to see the counts of all these letters. So to do that, it's probably help if I spelled system correctly. We're going to print the line, and we're just going to print M. Okay, so quickly, I know I did this fast, and you might not really understand exactly what's going on, but we're just looping through every letter in this string. We're going to check. The first check is going to see if the map contains that letter already, so as a key. If it does not, what we're going to do is we're simply going to add in a key, and it's going to be equal to that letter, and it's going to have a value of 1. Because we just found it, it occurs 1 time, we already know that. Now, if for some reason, or if that key does exist, what we're going to do is we're going to get that previous count, and then we're going to add 1 to that previous count and override the key. So like if the count is 4, it goes up to 5. Pretty straightforward. So if I run this, you can see we get space. Well, there's 8 spaces. We get A, there's 3 A's, C, there's 1, D, there's 1, and it goes through and it counts all of the different letters for us. And if we wanted to confirm if that was correct, we could go through and count them like that. And just by looking at it here, it does look as though that is correct. So yeah, that's a really common way to use a map. Yeah, it's really useful, and there's a lot of cases in which you want to do something like that. Okay, so the next thing I want to show you guys is something I forgot to do in the last video, and this is literally just going to take like 10 seconds, but pretty much to remove an element from a map, you probably already guessed, but it's literally just m.remove, and then you just type the key. So I just felt like I had to say this because I watched back my other video and I realized I forgot to say it. So to remove an element, you do m.remove and just put the key. So if I wanted to remove like all the spaces, which actually wouldn't be a bad idea to remove from our counts, then if I do that, interesting why it's not letting me remove that. Let's try that maybe. Oh, it's because it's a character. My bad. Sorry guys. I've been doing string. A character with space is different. Yeah, so then it actually removes the that character, the space, from our program, or from our map, whatever, okay? Now, the next thing I wanted to show actually is sorting. So sorting is something you typically want to do on arrays. So I'm actually going to remove all this, and I'm going to create a new array, an integer array. I'm going to say int x equals, in this case, let's do like 3, and let's do a bunch of different values and see if we can get this to sort for us. Let's do -99, semicolon there for us. And to sort this is actually really easy. All we have to do is just type arrays dot sort, and then what it takes is it takes 2 arguments. Now the first argument is obviously going to be our array, so in this case x, and then the other 2 arguments are actually optional. And what these do, sorry, so there's 3 arguments, not 2. What these arguments do is from a certain index. So if we wanted to sort just, let's say, like this part of the list that's highlighted, we can actually do that. And the way that we would do that is we would type 1, because we're going to start at 1. And then if we were going to 7, 1, 2, 3, 4, 5, 6, 7, funny enough, we would actually type 7. Now I know this is index 6, but the thing is, it's going to sort up, but not including to that index. So if we type 7, it's going to, that's 7, but it's only going to sort up to like the actual number 7, okay? And what this does, and I believe, is actually just changes the list. We don't need to say like x equals arrays.sort. We just say arrays.sort, and then what we can do is we can do system.out.println, and we can print x. And let's see if it did end up sorting that section of the list for us. Okay, so we actually, man, of course we can't do that. We're gonna have to set up a basic for loop to print these out, just because when we try to print arrays, I forgot we get that little loop, or we get that message because that's the memory address. But anyways, let's say for int I in x, and then we'll simply just print out I. It's got to make it complicated for us, doesn't it? And instead of printing ln, we're just going to print, and we'll just add a comma here just to make it separated. Okay, so let's run that. So there we go. So it actually did sort this middle section of the list for us, right? So we got 1, 2, 3, 4, 5, 6, 7, and you see 8 and 0 were not touched, and -99 was not touched. Now, if you want to sort the entire thing and you don't want to worry about these indexes, you can just put x. In this case, if we do this, we're going to get -99, 0, all the way up to 8. And yeah, so you could sort like from 3 to 5 or 3 to 6 or whatever, okay? And you can see it's only going to sort like a few of the elements in the list for us, or in the array for us. So that's a really useful way to sort things quite quickly, actually, and quite easily using just arrays.sort. And remember, you don't have to do like x equals arrays.sort, because what it's actually going to do is just sort in place all of the elements of x and swap them around, rather than creating like a new version of x that is sorted. We are going to be introducing object-oriented programming and talking about what objects are and getting a little bit into classes and methods. So I think the first thing to really talk about is what is an object. So an object essentially is just an instance of a certain data type. So we know we have data types like int, strings, bools, scanners, like all kinds of different things that we can use, like array list, hash table, hash list, whatever, hash map, all that stuff, okay? And those are all known as data types, right? Or classes, if you want to say that. So whenever we create an instance by doing something like this, like scanner sc equals new scanner, essentially what we're doing is pointing this variable sc to a scanner object, okay? And whenever we create any kind of variables, like just typing like int x equals 5, we're essentially saying x is equal to an int object of value 5, okay? And these objects are what allow us to have different properties for different data types. So you know how we can add integers together, or how we can do like .parseInt on strings, and we can have like a bunch of different methods and stuff. Those are all specific to the type of object that we're using. So for example, we can see here I have this scanner object, right? So sc is equal to a new scanner object that's taking system.in as an argument, okay? So we can only use this .next method on sc because it is a scanner type. If I try to do x.next, and I do a little semicolon here, you can see that we're getting can't invoke next method on primitive type int, because, well, that method doesn't exist for int, okay? And that's like a really basic way to kind of understand what objects are. Essentially, whenever we're creating a new variable, so like even just doing like string, like str equals hello, what we're doing is we're saying, well, str is actually equal to a string object with the value hello. And because or based on the different types of objects, we have different properties, different attributes, things we can do with them, methods we can call. And that's just kind of important to understand. You'll see more how we create like objects and whatnot that are specific to like classes that we're going to make in later videos. Okay, so it'll all start to come together, but just now kind of know that when I'm calling things objects, essentially that's like you have a variable of a certain type and it's equal to something, you're creating an object of that type. Okay, that's all we kind of have to understand for now. So now let's talk about methods. So some of you may already understand what methods are because I think I went through a very brief like explanation of them in previous videos, but essentially methods are anything that you call on an object or on an instance of an object. So just to clarify what an instance is, when we're creating a variable like this of a new scanner object, we can say that we're creating sc is now an object, like a scanner object, or we can say sc is a new instance of scanner, of like the type scanner. And those kind of are interchangeable. So if I say instance instead of object, they're very similar. Okay, so just bear with me on that. So anyways, when we call this .next method, we call it on the like variable, right? So that's pointing to our scanner object. So our scanner object allows us to use this method. Again, I showed you before, if I tried to call that on, for example, the variable x that was like an integer, that doesn't work because that object doesn't have that method associated with it. So a method is anything really that's just like a dot and then whatever the method name is and typically brackets. For example, if we had like an array, like say we have, or let's do actually a string. So we'll just type another string. Probably shouldn't have deleted all these, but that's okay. Let's say string h equals hello, and I can do something like h dot at length. And this is a method that simply returns to us the length of the string. And again, this works on our object, which is a string, but it's not going to work on our sc because, well, what is the length of a scanner? So if I type that, you can see that we're getting this red line here, and that's obviously not giving us anything because this length method is not defined for a scanner type. So that's kind of a bit about like how we call methods, and you guys have already seen a lot of different examples of methods that we can use on different objects and different data types, okay? And same thing when I say like data types and objects. Data types are kind of like what the object is created off of, and you'll see that more in future videos. Just want to clarify in case anyone's kind of confused, okay? So how can we create our own methods? Well, currently, since we don't really know anything about classes, we're going to be creating methods inside of this main class, okay? Now, this main class is special because it contains this method. And remember, I was telling you guys at the beginning, this method automatically runs whenever we run the program. Well, that's different than other methods we're going to have in classes we create in future videos. So it's a bit hard to explain this method per se, but this is a method because a method is typically anything that sits inside of a class. And the class is what's going to define like our data types. So scanner, in Java, we can't see it right now. There's actually somewhere that says public class scanner, and inside of that scanner class, so if you do like brackets like this, it has a ton of different methods, a ton of different attributes that we can use by calling them from within this function, okay? So if we want to create our own method within this main class, what we can do, and this is just the default way that we're going to do it for now. I'm going to show you why we use certain keywords and stuff in future videos, but it's a bit advanced right now. We're simply going to type public static, okay? And then whatever return type we want, which we'll talk about in a second. So in this case, I'm just going to do void, and then the name of our method. So in this case, I'm going to say like Tim, okay? So we have a public static void Tim. It has 0 parameters. Again, talk about that in a second. And then it's going to do something in here. In this case, I'm just going to say system.out.println, and we'll just say, when you call that, it just says Tim, like that, okay? So what I've essentially done here is create a static method that we can call from anywhere within this class, okay? And actually outside of the class as well. So what we need to do to call this method from inside this class is we can literally just type the method name. So in this case, if I type Tim and I put a semicolon like that, and we run the program, you see that we get, is it running? System.out. 1 second here, sorry. Okay, so I figured out why it wasn't working because we had this sc.next coming in here. So I'm just going to comment that out for right now. And we will run this one more time. And you can see that we get Tim to the screen. Now, I know I didn't really explain what this is or how this worked, but essentially what I've done here is I've created kind of like a function, okay? And it's known as a method, but in other programming languages, you might see this as a function. And this void keyword, what this means here is it returns nothing, okay? Because in functions, we can actually return values, which I'm going to show, or sorry, functions, methods, we can return values, which I'm going to show you in just a second. So this stands for, we are going to not return anything, we're just going to do something in here. So in this case, we're just printing something to the screen, all right? Now we have Tim, and this is the name of our method. And that's what we call here to trigger this to run, right? So if I wanted to pass some information to Tim, so say I wanted to print whatever string I passed to Tim, well, what I would do in here is I would type string, and then let's just say str, like that. And now this means that whenever we call this Tim method, we have to actually pass it one piece of information, and that piece of information has to be a string. Okay, so I'm going to show you right here. So I type str, I put Tim, and I put Tim in here like this, okay? And we run the program. Now we see we're printing out Tim. If I change this like with a bunch of M's, you can see if we run this, we're getting Tim. Now the way that this works is this is called a parameter. So str is a parameter of type string. And that means that whenever we call this function, we have to type in arguments. And what arguments are is what the parameter is going to be when we get to the method. So anything that goes in here in the call statement, which is what this is known as, where we're like triggering the method to run, is known as an argument. Okay, so Tim is an argument. When we call this, what's happening is we're passing Tim as str. So now it's saying like str equals Tim like that, or whatever the string is, okay? And then we're simply going to print to the screen whatever it is that we were passed. So in this case, Tim, right? Now we can actually do multiple parameters as well. So if I wanted to do another parameter, I wanted to pass two pieces of information every time we call this function, I would say maybe int and x, okay? And now it means that I have to pass not only a string, but I have to pass an int. So that means we have to type an integer in here. In this case, I'm going to do 4. And what I'm going to do now is I'm going to say 4, and we'll say int I, and we'll say I is less than x, and we'll say I plus plus. We're just going to print this that many times, okay? So let's see here. Boom. Okay, so system.out.println. What are we getting here? Initialize variable. Gotta do that, sorry. Okay, so now we pass an int, and we pass a string, and what we're gonna do is simply print this as many times as like the int that we typed in, okay? So you can see that now we get Tim 4 times to the screen, and that's how that works. So we have arguments in here. The two arguments are Tim and 4, and then we have our parameters, which are str and x, and when we pass our information in, str gets equal to Tim, and x gets equal to 4. Okay, and then in here we can now use those values by referencing str and x like I've done so, okay? So I hope that makes sense. Now in terms of this public static, I'm going to talk about this in the next video. For right now, all this means is that you can call this not on an instance of the class, which is kind of what we're doing here when we're just calling Tim, okay? Because we don't have any object that's like a class main, which you'll see in the next video, okay? So that's kind of how we can create our own methods. Again, we can create methods that return things. So that's what I wanted to talk about now. So all I'm going to do is I'm going to create another method, and I'm going to say this is public static. And in this case, I want to return an integer value to whoever's calling this, okay, or wherever this is being called. So I'm going to type int, because this is what I'm going to return, and the function's going to give back to us, or the method's going to give back to us. And I'm going to say add2 as the name. And we're simply going to take an integer x as our one parameter here. Let's see what the issue is here. Method must return. Yeah, okay. So you can see it's already giving us a red line saying that we have to return a value in this method because we typed in the fact that we were going to turn an int, okay? So what I'm going to do here is I'm simply going to return x plus 2. And what this is doing now, semicolon, is it's just taking a value x and it's adding 2 to it, and it's returning the value to our program, wherever we call it. So let's just do something up here and show you how this is working. So I'm going to say system.out.println, and here I'm simply going to type add2 and then give it a number, in this case 6. Now you can probably guess what this is going to give us, but essentially what's happening here is we're calling add2, we're giving it the value 6, so our argument is 6, it's coming in here, and the parameter x is now set equal to 6. We're going to return, so back to wherever we called this, x plus 2, in this case 8. So we get 8 here as a value, and we go boom, and we bring it up here, and now this little line is equal to 8, so we're going to print 8 to the screen. And you can see that we get 8 as a value like that. Now obviously in methods like this, you're probably going to do some more advanced things than just adding 2, but that shows you how we can return values. And I'll do one last example of returning maybe like a string value, so public static string. Okay, and we'll just say str as our name because I don't really know what to do, and we'll take a string x, okay? And then in here we have to return a string value, so what we could do is we could return x plus and an exclamation point. But I think I need to put that in double quotation marks like that. So what we're doing now is we're adding an exclamation point to the end of our string, and we're returning that. So if I call str here, okay, so I don't know why it keeps doing that with my brackets. We'll do str, and then inside our brackets, we'll give it hi. It should return to us hi with an exclamation point, and indeed it does. And yeah, that's kind of how methods work, basically. We're going to be going over classes. We're going to be talking about creating classes, creating some methods, constructor methods, all that fun stuff, creating instances and objects. And yeah, so this is going to be kind of an advanced video. If you've been following along so far, you'll definitely be able to follow along with it, but just know that now we're kind of getting into some harder aspects of Java. So if you guys don't understand this, please don't hesitate to join my Discord server, ask me some questions, leave a comment down below, because this is absolutely fundamental and you have to understand this before you can really start doing any serious programming. And that goes for kind of all languages, but Java especially, since it is an object-oriented language, we need to understand classes and how to create classes. So without further ado, let's get started. So far we've been working in this class called main. Now this is not really a true class, because this class, all it's doing for us is just running some code right away when we run the program. And that's why we have this public static void main function that automatically triggers whenever we click this little green run button. Okay, so what I'm going to do now, and you can see that I have some methods that I've added in here that we just kind of use within here earlier, okay? What I'm going to do now is I'm going to create my own class from scratch, and we're going to start coding. So to do this, we're going to go to whatever our package is. So in this case, tutorial 1 for me, and I'm going to go new and class, and I just did that by right clicking. And now I'm going to give my class a name. Now for this example, I'm going to create a dog class, and yeah, you guys can create whatever you want, but I would recommend you follow along with me since you guys are most likely new to classes. Okay, so now we have this thing and it says public class dog, and you can see that we open up in a new file. So whenever we create a new class in Java, we have to actually create a new file for that. Now it's actually good because it makes it really easy to navigate between different classes, whereas in something like Python, you can just have all your classes in one file. Okay, so what we're going to do now is we have this public class dog. So what does this mean? Like, what is a class? Well, a class is pretty much a data type, and whenever we create an instance of a class, so like an object of a certain type, all we're doing is we're just using all the information within the class to like create an object. So you can almost think of it as like a blueprint for an object. Now, what problems do classes solve for us? Like, why are they useful? So I'm going to introduce kind of a very simple problem, all right? So I want to create 5 dogs. Okay, I want to have 5 dogs. I want each dog to have a name. I want each dog to have an age. And I want to, at some point, be able to like call something and print out each dog's name and age in like a nice form, okay? Now, we could do that. We know how to do that. If we went back into main here, what we could do in this little, method here is we could just type a bunch of ints. We could say int like dog1. And this is equal to 4, and that's dog 1's age. We say int dog 2, and that's equal to 5. And we could go on and we could create 10 variables, 5 for the age and 5 for the names, right? And then we could go and we could print out each one each time, but that is incredibly inefficient. And what if I wanted to have like 10,000 dogs? Well, what would I do then? Well, we could use like lists to create, or lists or arrays to create names and ages, but that's just not efficient. It doesn't look as good in our actual coding. So what we're going to do is we're going to use a class, and you'll see how we can kind of accomplish this problem. So within classes, we have methods and we have attributes, okay? Now attributes are kind of like variables that hold information for us. So in this case, we want to have 2 attributes in our dog class. And these are going to be the name and the age. To create our attributes, this is the first thing we typically do when we create a class, is right at the top of our class, we're going to type the keyword private, and then we're going to give a data type. So in this case, I'm going to say string, and then the name of our attributes, in this case name. Okay, and this is all we have to do. We're just declaring that at some point in time we're going to have the attribute name, and it's going to be storing some information later on in our program. Okay, we can also do private int, and in this case I'll do age, and this is going to obviously represent the dog's age. Now if you wanted to have some other attributes, we would again type private, and we could keep going and type a bunch of attributes. Now what is this private keyword, and why do we have public up here and private here? Well, what this private keyword does is it ensures that this name and this age are only accessible within this class, meaning that if I tried to do something over here and I wanted to use this age and this name from this class, I wouldn't be allowed to do that, and the program would say, no, this is a private attribute, you can't access that. Why do we do that? Well, you would find out in larger programs, but we can also create public attributes as well that are accessible to the other classes. Okay, so if I wanted my things to be public, I can put public. For now, whenever we're using attributes, we're going to use private, and it's best practice to use more private things. Okay, and same goes for methods, which you'll see in a minute. Okay, so now I need to create something called a constructor method. Now this, you typically only create one of these, although you can create multiple. And what this is going to do is it is going to run automatically whenever we call this dog class. And the way we create this constructor, and we typically need one of these when we have a class, is we're going to do public, and we're just going to type the name of our class once again. So in this case, I'm going to say public dog, like this, okay? And you can see that now we're getting no errors, everything's fine. And in here, we are going to type the parameters or the information that we need to be passed in whenever we're creating a dog object. Now, in some instances, you may have nothing in here. When you create a dog object, all you need to do is just say you're creating a dog object. You don't need to give any information, and that's fine. But in our case, we want to be able to create an age and a name with our dog. So what I need to do here is I need to type string name and int age, okay? Just meaning that whenever we create a dog object, we need to give it a name and we need to give it an age. Now what I'm going to do is I'm going to set these values, so these attributes, equal to whatever we pass in. Okay, so what I'm going to do is I'm actually just going to use a keyword, and the keyword is this. It's kind of hard if you weren't watching, you'd think I'm just like saying this is the keyword and pointing something, but this like actually typed out. And then I'm doing this dot name is going to be equal to name, and this dot age is going to be equal to age. So what is this this keyword actually doing? Well, it is referencing the attributes of the class. Okay, so when we type this, it is going to be looking up here to find all of our like private attributes. And in this case, we have an age and we have a name. All right. And that's how we reference things that are a part of the specific instance. We have this dot name and this dot age. Okay. And I'm going to explain more and more of this as we keep going. It's hard to do it in like small steps. Okay. So now that I have this constructor method created, we can go on to create one more method, and then we can actually start using this class really simply, okay? So what I'm going to do now is I'm going to create another method. In this case, I'm going to type a public. I'm not going to return anything, so I'm going to use void, okay? And the name is going to be speak. And what this is going to do is it is simply going to say something or print something out to the screen. So I'm going to say system.out.println. Why did that? Okay, println. And all we're going to do is we're going to say I am, and I want to say the dog's name. So in this case, we'll say this dot name, okay? And we'll say plus, and I am, do another plus, we'll say this dot age plus years old, okay? So it's simply going to say like I am, whatever the name is, and I am however many years old. Not great grammar, but that's fine. So now, how do we actually create an instance of this, or how do we use this dog class? Well, from our main class here, which we should still have open, and you know what, we can delete all these, we don't need all that, so we'll get rid of all this stuff here. We can actually create a object, and to do that of type dog, what we're simply going to do is we're going to type dog, and we're going to give it a name. In this case, I'm going to say Tim is equal to new dog, okay? And then remember that we have to give dog some parameters, right? So, or arguments, because we have the name and we have the age. So what we need to do is we need to give it a name and an age. So in this case, I'm going to type Tim, and I'm going to type 4. And now you can see no red line. We're looking good. So our dog's name is Tim and its age is 4. Okay, so that's great. Let's run the program, make sure this is working. Everything's fine. Now, what I want to do is I want to use that speak method. So how can I use that? Well, what I'm going to do is I'm going to type Tim, which is the name of my dog, or like the variable for it, dot speak, like this, okay? Semicolon. And let's see what happens. We get I am Tim, and excuse me, I am 4 years old. So the way that this worked, right, is we created a instance of the dog class, and the instance was named Tim, and it referenced a dog object, okay? So now when we created that instance, we said, okay, so this instance, this specific one, is going to have an age of 4 and a name of Tim. All right, so it stored that information up here in our private string, in our private int. And then later on, when we decided we wanted to call this, well, it said, okay, well, give me the instance you're calling it on. So in this case, we're calling it on Tim. We're going to say, okay, so Tim, what's Tim's name? Well, its name is, well, it's Tim. Okay, so we'll say Tim. What's its age? Its age, that's 4. So we'll print 4 to the screen. Now we can obviously create multiple dog objects. So let's copy this and let's create a few more. We'll create 3 dog objects. I'm going to say this is Bill, and he is 7. And we'll say this is Bob, and he is 11. Okay, let's copy this, and oh, I keep naming them the same thing. Let's go Bob, and let's go Bill, and then we can simply call the speak methods on them. Okay, so we'll say Bill, and we'll say Bob. All right, and just to prove something, I'm going to say tim.speak again, and we'll talk about why I do that in just a second. Okay, so let's run this. We say I am Tim, and I'm 4 years old. I am Bill, I'm 7, and go on, and you can read through them. Okay. Now notice when we call Tim again, it still retains its age and its name. When we do this, we're not actually changing, like this is not one variable. We actually now have 3 different names, right? We have Tim, we have Bill, and we have Bob, and they're specific to each of these variables that are storing that dog object, okay? So that means that we can hold like unique values for each of our different instances, and we can have like infinite amount of instances of a class, okay? All right, so that is about it. I think I'm going to talk about quickly. I already talked about private versus public. Let's create some more methods in here and see what they can do. And I'll talk about a bit more about constructors because we're only at like 11 minutes. So what I'm going to do now is I'm going to create another method, and I'm going to call this get age. Okay, so I'm going to say public, and in this case we'll say int get age. All right, and all we're going to do in here is simply return the age to let's see, a return statement to wherever we're calling it from. So in this case, all I'm going to say is I'm going to return this dot age. Now the reason I need to do this is because say I want to get the age of one of my dogs, right? Like say I created it, I changed it around, I don't know what it is, I want the age. Well, we can't simply do something like in other languages, we'd be able to do like tim.age, right? Now you see when we do this, we get these little red lines, and it says the field dog.age is not visible. And that is because, again, it's private, so it's not letting us see it from over here in this main function. Only within this, method, only within this class can we actually reference this variable, right? So to get the age, what we can do is we can call tim.getAge like that, okay? And we can print that to the screen. We say like int x equals, I'm gonna say system.out println, and oh, x is already there, great. So now if we run this, we can see that we get 4 down here, excuse me, at the bottom of the screen. Now we can actually do the same thing with like setting the age. So say we wanted to change the age at some point, maybe Tim got a year older. Well, what we would do is we have to create another method in here. In this case, we're going to make it public again. We're going to say public, and we don't need int this time because we're just going to change something. We're not going to return something. We'll say public void, and we'll say set age, okay? And then we're going to take an age because we need to know what we're going to set it to. And we'll just say this dot age equals age. So just like we've done up here, it's the exact same thing, except we're just going to do it within the method set age. So now, if I want to change the age, so let's say instead of that, we'll say set age, and we'll give it a value of 10. Then we print out, let's just say tim.speak again. What's going to happen now? Sorry guys, I'm a bit sick if I keep coughing all over the place. What I'm going to do is, oh. What's our error? Tim.setAge 10, return type of set age to int. 1 second here, sorry. Public, let's try this. Int set age, public void. I know I'm making a mistake over here. Oh, okay, that's why. I can't set equal to a variable. I have to call like tim.setAge. My bad on that, guys. We do speak. We can see now it says I am Tim and I am 10 years old, and we've changed from the age of 4. So that's how we would go about changing these attributes later on within the class, okay? Now I want to do one last one. I want to create a private method and show you what this is, okay? So I'm going to create a private void, or actually, no, let's do int, okay? And we're just going to call this add2. It's not going to make any sense with the dog class, but it's just for an example, okay? And in here, we're going to take, actually, we won't take anything, but what we're going to return this dot age plus 2, okay? Now this is a private method, meaning that it can only be used and seen within this dog class. So say I wanted to use this add2, maybe I could do this. I could do add2 here, okay? And just do a little semicolon, and there we go. I could use add2, and that works fine. There's no issues with that, okay? And that's how you use methods within side of the class. So like speak, I could easily, every time we initiate the dog, call the speak method as well. And to do it within the class, you don't need to do like something dot, you just call the actual name because it's really visible within here, right? Now, watch what happens if I go over here and I try to use that. So add2. So I'll say tim.add2 like this. And you can see that, again, we're getting a red line and says this is not visible. You can't use it because it's a private method, okay? So in today's video, we're going to be going over inheritance. So this has to do with classes, and this is going to be how we can inherit methods and attributes of previously made classes into like a new class, and then override methods and all kinds of fun stuff. This is really important. This will save you a ton of time. And yeah, so let's get started. So you can see here I have this, this dog class that we created in the last video. And pretty much the goal, what I want to do at least in this video, or the problem is, I want to create a cat class that is identical to this dog class, except in this speak method here, instead of saying I am whatever, I just wanted to say meow, my name is whatever, right? So I just want to change one of these methods to do something different, but other than that, I want all of this to be the same. So intuitively, what we think we do is, well, we just take all this, copy it, put it into a new file called cat, and then just change this to be what we want. Well, we could do that, and that'd be fine. But when we have classes that are like thousands and thousands of lines long, ideally, we don't want to be repeating code and continually typing like the same thing a bunch of times, right? It also just makes it more difficult to read. So what we're going to do is we're going to use something called inheritance. So I'm going to create a new class. I'm going to go new class. And in this case, I'm going to call mine cat, all right? And I'll just click finish like that. And in here, we have public class cat. Now, whenever we do this inheritance, what we can actually do to inherit all of the properties, all of the methods, everything from this dog class is up here when we define the class, we can type extends, if we spell it correctly, extends, and then the class dog, like this, okay? Now, what this is going to do is it is going to grab everything from dog class and apply it to cat class. So this is known as our super class because it's kind of above the cat class. And then cat is known as our subclass. So we have, you can also call it a child class or a derived class, and this could be also called a parent class, all right? And that's because it's kind of underneath, it's getting everything from there, but then it's going to be changing a few things and maybe adding a few methods to it. So typically you start off like the most abstract with a parent class, and then your child classes or your derived classes or your subclasses, because they're all the exact same thing, just everyone likes to use different words for them, are going to have some slight modifications to them and kind of work based off of that superclass, right? So, or the parent class, okay? So what we need to do when we first do this is you can see here, it already is telling us we need to use the constructor for dog. So we're inheriting from dog, but we need to use the same constructor. Otherwise, all this stuff and all these attributes, well, they're not going to work unless we set up our class when we first create it the same way as we did dog. So what I'm going to do is I'm actually just going to click on this, and you can see it automatically generates this constructor for us. Now I could have typed it out, but this is, this is what it's going to do. So since in our dog class, we get name and we get age, we need to make sure that we have a constructor inside of our cat class that gets name and gets an age, and we have to actually explicitly call our superclass constructor, which is going to be the dog constructor, using this formation or this syntax, super, and then we give it the name and we give it the age. Now, this doesn't stop us from being able to type in other properties or other attributes. So for example, I could do something like int and, I don't know, food or something. It's like how much food they should get. And this works perfectly fine. And we can go ahead and we can create another attribute here. So we say private, I don't know, let's just say food, okay? And this should say int food. And then down here, we can go ahead and we can just type this dot food equals food, okay, right? And that works perfectly fine. And now we're gonna have, since we're inheriting from this, we're gonna have age, we're gonna have name, and inside of this cat class, we are gonna have food as well. And that works just fine, okay? So just to, I don't know, let's go over this again because I think I've kind of gone through it pretty quickly, but all of these methods here, we're going to be able to use within our cat class because, well, we're inheriting, we're grabbing all of them from the dog class. So this cat class, when we first extend it and do nothing, is identical to the dog class. And then as soon as we start changing a few things in here, it's going to become a little bit different, but still use all of this functionality. So we still have the attribute age, the attribute name. We're setting them equal because we're going to call this constructor method, right, from our, what do you call it, super right here. So we call this constructor. So we set up age and we set up name. And then we have speak, we have get age, and we have set age. Now, before I move any further, let me just prove this to you. So if I go to main here and I just create a cat object, so I'll just say cat Tim equals new cat. And remember, we have to give it 3 parameters or 3 arguments this time because that's what we typed in. So for name, we're going to obviously do Tim. Age, we'll do 18. And food, let's say they get 100, I don't know, grams of food or something, whatever you want to say there, okay? Now I can use this speak method on Tim. So you see, we're getting no errors here, even though in my cat class, there's no speak method. But since there's one in dog and we inherit from it, we can use it. So I'll prove again to you. Run this. I am Tim and I am 18 years old. And that works perfectly fine. So now remember I said, though, I want this speak method to do something else. I want to change it. So how can we do that within the cat class? Well, the way to do this is to just rewrite the method in here, because when we do that, we're simply going to overwrite whatever's in the dog class. So the child class or the subclass, whatever you want to call it, whenever there's something the same in here, it automatically is going to override or overwrite whatever's in the dog class. So if I do public void speak, okay, so this is the exact same name as the other one. All right, and in here, I change, I do something, right? So I change something. So I'm just going to say system.out.println. And in here, what did I want to say? Like meow. And my name is, I'll just say plus this dot name. And you know what? We'll even add like a little food thing. And I get fed, I don't know, let's see here, plus this dot food. Okay, I don't know, that's good enough for me. What's the issue here? Change visibility of name to protected. Oh, okay, 1 second, I gotta do something here. Cat, this just needs to be, sorry, public and public. Sorry, this is just because we're not actually able to see these attributes because they're defined in the dog class from within our cat class. So we just need to change them to public so that we're actually going to be able to use them within our speak method. We can also use something called protected, which I'm going to talk about near the end of this video. Okay, so right now we'll just use public because I don't want to get into protected, but let's see what happens now if I run my tim.speak. Now we can say meow, my name is Tim, and I get fed 100. Okay. And that's because even though in the dog class we had speak, since we wrote it again in our cat class, and cat class is the one that we're using, we're simply going to take this one and we're going to override the one in our dog class. Okay. Now, obviously, when we're doing inheritance, you've already seen we can add our own methods and we can add more stuff and we can do whatever we want, right? So in here, I can add more methods. I can say public void, I don't know, eat. And in this case, we'll just have like int, I don't know, x, like as how much they're eating. And we can say this dot food minus equals x, okay? And just subtract from it however much they ate. And then we can use eat in the cat class, but it's not going to be seen in the dog class, right? So we just have to understand that this does go one way. All the stuff we do in the cat class is not going to be visible to stuff in dog class because, well, dog does not extend cat, right? So it's kind of a hierarchy where like dog's at the top and then cat branches off, and we could have other things extend the dog class as well. We could have something extend the cat class. And we could just keep going and going and going and extending and extending and extending, also known as like inheriting, right? So that's kind of it for inheritance. Now I want to show something called multiple constructors, okay? So there is sometimes when we're setting up a class, we want to be able to pass it like a different piece of information and set up the class differently, right? So for example, my cat class here gives name, age, and food. What if, however, I only wanted to give it name and age? Well, we can leave both options available. They don't have to be mutually exclusive, right? I could give it either these 3 arguments to set it up, or I could give it just 2. And to do this, we have to create another constructor. So I'm going to do the exact same thing as above, pretty well identical, except I'm just going to leave out one of the parameters here, okay? So we'll say int age, and then in here we'll simply call super and name and age, okay? And you can see no red lines, everything looks fine. And what we're essentially doing here is we're giving it another way to set up the cat class, another way to construct all of our attributes and set up the cat class. So we can either call the cat class using 3 parameters or 3 arguments, or we can call it using 2. And you know what? Maybe we could set one up only using 1 or only using 0. So let's do one with 1 just to show you how this might work. Okay, so if I do string name and then int age, okay. And then here I call super. Oh, sorry, I should actually get rid of this because we're only going to use 1, right? My bad. I'm going to give name, but what about age? What am I giving super for our age? Well, I don't know. How are we going to set it up if they only give us 1 argument? Well, I would think that if they don't give us an age, then we should just automatically assume that their age is 0. So let's do that. I'm going to put in 0, just hard code that in here. So that way, this means now, say for example, they only want to give us a name, then we'll just automatically give them an age of 0. If they want to give us a name and an age, that's fine, we can do that. But maybe what we should do in here, if they give us a name and an age, is we should make sure that food is set equal to, I don't know, maybe let's give it a default value of 50. So if they don't define how much food the cat eats, we're just going to assume that they eat 50, okay? And this is kind of a way you can do, like, it's known as like default parameters. If they don't type something in, just automatically set a value for that so that everything still works fine. I hope that makes sense. So let's show now the 3 different ways that we can create a cat. Say cat Bob equals new cat. And in this case, we'll give it a name. So we'll say Bob, and we'll give it an age of 7. And no red lines, this works fine. Again, this defines a cat, right? Because that's another constructor that we had. So let's do this one more time. And in this case, let's just only type in a name. We're going to name this one Joe, like the name Joe, all right? And there we are. So now we could obviously do like bob.speak, and we could do joe.speak. And these are the 3 ways that we have that we can define a cat, okay? So meow, my name is Joe, I get fed 0. Bob, I get fed 50. Right, we can go on like that. So again, when we have 1, now we just seen a quick error that maybe we want to fix. We should probably give them food as well. So we say this.food equals 50, okay? As like our default value for how much they get fed. So that is a way that you can do multiple constructors. And now I'm going to talk about protected values. So protected values are something that we can use similar to private and public, but they just act a bit differently. So pretty much if you use the protected keyword instead of public when you're defining things. So for example, here in my dog class, I'm going to go up and change public to protected. This means that only things that are within the same package or are subclasses of the class can have access to this, pretty much, like name. Okay, so that means any of these files or any of these classes within this package are able to see this. But if I had another package, which you typically do if you have large Java programs, anything in there would not be able to see this, okay? So whenever we're using, what do you call it? Whenever we're creating like a main class or a parent class, protected, wow, okay. We're gonna wanna use the protected keyword at least for, what do you call it? Sorry, our attributes, so that we can change them and access them from within the subclass, all right? Now for these methods, it's fine, they're public anyways, right? So we can make these protected as well if we didn't want another package to be able to access them. Now, if we create private methods, right? If we create a private method here, I'm actually gonna try this because I don't remember if this is gonna allow us to use this now out here. So let's say like Tim dot, I don't even know which one I changed, get age, okay? Say Tim dot get age, say int x equals, let's see if this is gonna work. Yeah, so again, this is not gonna allow us to use this because, well, we made it private, right? If we made that protected, it would allow us to use it here, but not outside of the package. Now, I wanna try this though and see if I can get this, use this get age from within our cat class. So if I do, for example, when I wanna speak, I'll say this dot get age, and yeah, so this isn't working as well, which means that, again, if we want to use those methods, we have to make sure they're either public or protected rather than private, okay? The only time you're really going to create private methods is if within the class is the only area you're using the method. So for example, maybe you're doing like a math calculation and you only do that from within the class and you don't want anyone outside of the class to be able to do that, then you create a private method to do that because you could do that from within the class, right? So in today's video, we're going to be going over kind of class variables and the keyword static. So you may have seen that we've used static in a few things in like our main thing here. Actually, I got to delete all this. It says static right here. And no one's really explained, or I guess I haven't really explained what static means. And that's what I'm going to be doing in this video. So let's get started and talk about class variables. So right now we have something called attributes. Okay, so we have these two attributes which are specific to each instance of our dog. So when we created multiple dog objects, each dog had their own name and their own age, and other dogs were not affected when we changed one of the dog's name or one of the dog's age, unless that dog was them, obviously, right? And that's great because we can have a ton of different values that are specific to different objects or different instances of this dog class. Now, sometimes we want to have variables that will change or are the same for each instance. So we can change them in one instance, and if we do change them in one instance, they will change in the other. Now, those are known as class variables, not instance variables, because instance variables are like kind of attributes, okay? The way that we can create these class variables is we can do something like this. So I'm going to say protected again, say protected, and by the way, I'm just in my dog class. I deleted a bunch of stuff out of it just to make it a bit easier to work in, and I still have the cat class, but it's just, I'm not using it for this video, okay? So we'll say protected static int count equals 0. Now, I know that that is a mouthful, but what we're doing here essentially is we're creating a class variable, which is an int named count equals 0, which is protected, okay? I know it's a lot of keywords, but what does this static keyword do? So what this is actually going to do is it's going to allow us to statically change count, which means it's not going to change for each instance. It's only going to change, it'll change like all together, right? So what I was explaining before. And that's what this static keyword is going to allow us to do. So we don't actually care about what instance this variable is a part of. We just care that it's a part of the dog class, all right? So if I want to change this value, x, well, I do still need to call this, and I can say this dot count equals, and then, or actually I'm gonna say plus equals 1, okay? Because what I wanna do with this count here, I'm gonna say static field dog should be accessed in a static way. Okay, let's just do this 1 second. Okay, what I'm doing here, sorry, 1 second, I'll explain this, is I'm just going to add 1 to this count because I want to keep track of how many dogs we have, so that if I wanted to, I don't know, like see how many dogs have been created, I could just simply call like dog.count and then figure that out, right? So what I'm doing here, instead of calling this .count, which does actually work, is I'm calling dog.count, because since this is a static variable, or static variable, class variable, whatever you want to call it, it doesn't actually care about what instance I'm changing it on, because it's going to change for all the instances. So I can actually use the name of the class to change it, and that's why it gave me that little yellow line. I'm not sure if you guys read that. It said we should do this in a static way because, well, it's a static variable. So I could, however, call like this .count, all right? And that would work fine because this, well, is an instance of the dog class, so it knows where to look for the variable count, but it's much better to do dog.count, like plus equals 1, okay? Now, I'm going to prove this to you, that this does indeed actually work. I'm not just making things up. So let's create some dog objects here. Let's say Tim, or dog Tim equals new, wow, the typing is not great today, new dog, and we'll just say Tim, and let's go 9 for age, and we'll just copy this, and what should we do? Let's do Bill, maybe. We'll say Bill, and that is new dog name, Bill, age 10, okay? Now, since this static variable here is protected, I can actually access it from main. So what I'm going to do to change count now, or to print count out, first of all, is I'll prove to you that system.out.println, I keep thinking we're in Python here, and I'll just simply print out dog.count like this, okay? And just see what we get as a value, first of all. Okay, so we get 2. So we already know that this is indeed working because, well, when we added 1 to count, if it was this different for each one, then it would just be 1, but anyways. And if I want to change dog.count, what I can do is I can say dog.count let's say equals like 7, okay? And that's fine, that works. If I print out dog.count, we get 7. Now I'll show you too, if I do like tim.count, this will give us the same answer. So you can see we get 7, even though in Tim, we didn't do anything with Tim to change count. Since it's a dog, part of the dog class, it has this count variable and it's changing obviously within Tim as well, okay? So that's kind of how the class variables work. Now time to talk about static methods, okay? So this was a static variable or class variable. I like to call it class variable just because that's what I'm used to, but you can call it whatever you want. Now we're going to talk about static methods and what that is. So it's very similar to this kind of the way that this works, but is a little different. So what I'm going to do here, I'm going to type public static void display, okay? And in here, all I'm going to do is simply do system.out.println, and I'll just print I am a dog, okay? So what this is doing now is I'm saying static void display. Now in here, what's going to happen essentially is we don't need an instance to call this. So I can actually just call this on the dog class. So I can say like dog dot display like this. And since it's a static method, this works fine. And this will indeed say I am a dog. Now, as opposed to if this was a regular method, so let's just make a regular method to kind of do a comparison here. So let's say public void, and we'll say display2, okay? And we'll literally just take this and put it word for word in here, just to show you the difference. So now watch what happens if I try to do dog.display2. You can see that we're getting a red line and it's saying that we need to make this static because we need an instance to call display2, meaning that we need to have first create a dog object, and then we can use that dog object to call display2, or we can do like this dot display2, and that works fine because that's calling it on the instance, right? Because this represents the instance that we're using. So the static is going to allow us to call it just simply using dog. But the thing with static is it has no way to access our our values or our attributes, right? So if I wanted to access like a dog's name or a dog's age, well, I can't do that from a static method. Like I can't type like this dot age. That just simply doesn't work, because if you think about it, well, what instance are we calling it on? There's no instance. We're just simply calling it on the dog class. So we have no idea what age to look for or what name to look for. So the only time we use static methods is when we don't care about the instance and we just want to do something and we want to store it within that class. You can almost think of it as a function if you know other programming languages, but that is ideally how static works. So whenever you want to be able to call something and you don't care about the like the instance, you don't care about the attributes, you can make it static, and that way you can call it without having an instance. So yeah, so hopefully that makes sense to you guys. I'll quickly go over what this void does one more time in case anyone forgets. Remember, in our functions we can return values. When you put void, all this does is say we're not returning anything, we're just going to do something, right? So we could be like manipulating an array, or in this case printing something out to the screen, okay? Or maybe getting like input from the user, but we're just not returning any value back to the call statement. So in today's video, we're going to be going over how we can compare objects and how we can get a string representation of different objects. And you'll see what I mean in just a minute, but these are really useful, and I guarantee you guys will be using this a lot, especially if you have objects like maybe like point objects or like some kind of mathematical objects that you'd want to compare without having to, I don't know, make things too complicated for yourself. Let's just say that, all right? So what I'm going to do here, or what I've already done, I guess, is I have this student class set up, and this is just what we're going to work with right now, because the other classes I had in previous videos were already like finished and they had other stuff in it. So we just have a student, and currently the only attribute the student has is a name, okay? Now in my main.java here, I've just created a few different students, and then I'm just going to be printing something out to the screen, so that's why I have that right now. So we can see student class, right? We just create a name for our student. Now I just want to show you quickly how we would go about like comparing objects intuitively, right? So say I wanted to check if Joe and Bill were the same, right? Like if I want to see if they were equal to each other. Well, we know how to do that already. So what I would do is I'd say like Joe is equal to Bill. Now intuitively, you'd probably say, well, no, their names are not the same, so they're not going to be equal to each other. And well, that would be correct, but not for the reason that you think, and I'll demonstrate that to you. So we have Joe and Bill compared to each other. So watch what happens if I make these the same name, right? So you'd think, well, these would be the same object or they'd be the same thing, right? Because they have the same name. But watch what happens when I run. We still get false. Now, why is that exactly? Well, pretty much when we use this double equal sign on two objects, right? So like Joe and Bill, the computer doesn't know how to compare them. So by default, what it does is it compares the actual object. And you see here how we're creating a new student, so a new object, and here we're creating another new student, another new object. These are actually two different objects like in memory, okay? So in your computer's RAM, these are two different entities and they're completely unique. Although, yes, they have the same name, since we can change names and we can do things, these need to be separate objects. So when we compare here, it's actually saying, well, we're going to look and see if these are the exact same object, and well, they are not. Now, that's useful in some cases because sometimes we want to see if it's like the exact same object, but in other cases, we want to see if these objects have like the similar values, right? So in this case, we'd probably want to compare the two names of the students to see if they were the same. And in that case, we would say, well, yes, these are the same student, or we're going to say, yes, they are the same, right? When we do the like double equal sign. So what I'm going to do now is I'll delete this. I'm going to show you how we can go about doing that. So inside of our student class, I'm going to add a method, okay? I'm going to call this public Boolean, not Boolean, Boolean. And we're going to say equals. And then here, we're going to take a student object known as other, okay? And then we'll go like that. And there we are. So what I'm going to do in here is when we want to compare our student, okay, we're going to pass another student and we're going to compare their names, right? So we're going to call this dot equals on one of our students that already exists. We're going to give it another student and then we're going to see if they're the same. So how did we say we were going to check if they're the same? Well, we were going to look at their names, okay? So what I'm going to do is I'm going to say if, and then we'll say this dot name, and I guess I need brackets here as well. Always forget about those. If this dot name equals, okay, and then we'll say other dot name, then what we'll do is we'll simply return true, okay? Now otherwise, so if these names are not the same, what we will do is we will return false like that, okay? And that's all we need to do for our dot equals. So now what's going to happen, right, is we'll pass on one student, we'll call this, we'll check the name, and then we'll check the other student's name, see if it's true. If it is, or if they're the same, we'll return true. Otherwise, we'll return false. So now we can try this out. So these two are the same names. So let's say is Joe dot equals, and then here I guess we will put Bill. So let's run this, and you can see we get a value of true. And then if I change Bill back to say Bill, then we can run this, and we can see we get false. So now we officially have something checking for equality between the names. Now we could create more kind of ones like this, like equals grade, like whatever, if you want to do that. But this is how we can check for equality between objects, and this method is like really easy to add in. Obviously, if you had a student with a bunch more values, so maybe you had like grade, maybe you had other stuff like that, or like a last name, you could check to make sure those are all the same, or you can just kind of customly do it the way that you want to say two different objects are the same, right? Okay, so the next thing I want to be able to do is compare things using like greater than sign or less than sign, right? So I want to see if like Joe is greater than Bill or Bill is greater than Tim, and we should intuitively like do that based on alphabetical order, right? So I can't really show you like a way to do it here because I don't think it's going to work if I do like Joe greater than Bill. Yeah, see that just is undefined. There's no way to do that. So what we're going to do is we're going to use a method called compare to, okay? And what we have to do to compare to is we have to, we have to implement something into our class. So we're going to say implements at the top of our class, and we're going to spell implements correctly, and we're going to type comparable, and then in here we're going to do student. Now what we're actually doing here when we bring this in is we're actually implementing something called an interface. Now an interface I'm going to talk about in I think like 2 videos from now, but pretty much it's just like a set of methods that we have to use for the class to work. So when we implement this comparable thing, that means we're allowed to bring in a method that is going to allow us to compare two objects, okay? So what we'll do now is we will say public, and actually what is the thing for this, the return type, public int and compare to, and then in brackets here, again, we're going to take student, and this will be other, and we'll put our brackets here like this, okay? So now again, we're going to have to return some kind of integer, and I'll show you how that works. I just got to get it up on my other screen so I don't mess this up. Okay, so what I'm going to do now is I'm going to return this .name .compare to, and in this case, we're going to compare it to another string. So the other string will be other .name, okay? So essentially what this is going to do is it is going to compare this name to this other name, and it's going to give us an integer value saying kind of how far away they are, right? So it's kind of hard to like explain, so I'm just actually going to do it from over here, and you'll see what I mean. So if I go Joe dot compare to, and then again let's do Bill, let's see what we get. So we get a value of 8. Now what this means is Joe is greater than Bill by a distance of 8. Meaning that when we compare these first two letters, they are 8 away, I believe, okay? So if we wanted to check if Joe was greater than Bill, what we do is we check if this integer value returned was greater than 0. So here, greater than 0, that's going to tell us true if Joe is greater than Bill and false if he's less. So we run this and we get true. Now, let's see if we compare Joe to Tim, okay? So T obviously is ahead of J in the alphabet, so we get a value of false, okay? And if we get rid of this greater than 0, then we can see exactly what we're actually getting as a value, so -10, right? Because that's how far away J is from T when we're comparing them, and that's what the compare to does for us, okay? So if we wanted to check if Joe was less than Tim, then we check if this value was less than 0, and in this case, we get true. So that's a really easy way that we can compare different objects using that compare to method, okay? So like this, so public int compare to, and you just have to remember to implement comparable student, and then you can use exactly this return statement here. Now the last thing I want to show is a string representation of an object. So I want to show you first what happens when I just want to print out my object to the screen. So I want to print Tim, and maybe ideally I'd like to see like Tim's name, right, come out to the screen. Well, look what we get here. We get tutorial1.student at, and then all these different letters. What this is printing is actually the memory location of our object. So all of our objects are actually stored in memory, in RAM, in like really fancy ways that I can't really explain to you guys. But anyways, this is like the address for it. It's like when the computer looks it up, this is what it's actually using to find Tim and find all its values. And obviously it's telling us where it is in the tutorial1 like folder file, whatever, okay? So this is no use to us. This does not help us as programmers at all. We want to see like something that's a string and gives us some valuable information. So what I need to do is I need to implement another method here that's going to change this to a string. So we've used this .toString before, but this is exactly what I'm going to use. We're going to say public string, and then we'll say toString like this, okay? And what we're going to do in here is we're just going to return a string representation of our object. So what we can do essentially is I can just return this .name, and this can be what we're going to use to represent our object. Now typically you might see people do something like this, okay, and just follow me for 1 second. They do student and they have a bracket, and then we're going to add this .name, and then they add that with another bracket here. So this way you'll see when I print it out to the screen what it looks like, okay? We get student and then Tim. And this is just simply telling us that the object that we're printing is a type of student, and the name value is Tim, okay? And we could even get more fancy, and we could add like double brackets around this .name if we wanted to show that this .name was a string type, okay? Now for our purpose, I'm just going to get rid of this student and this bracket here, and you can see again when we print this, it goes Tim. Now notice when I'm printing this, I'm not actually calling this toString method. Like I'm not doing .toString. That's because Java actually knows that when we have this toString method in here, this is going to represent a string, right? So when we try to print it, it's automatically going to call that .toString method, okay? So now what we can do is we can also just call like toString. So I can, if I wanted to, I could just call .toString like this, and I could convert it to a string, and this will work the exact same way as before. You can see we get Bill, okay? Again, in here, you can change this up however you'd like. In some cases, like say your student had some grades, maybe you wanted to write their name, and then after you have like an array of all their grades or something like that, okay? Now, inner classes are pretty easy, actually. All they are is really just a class inside of another class or inside of a method, and I'll show you some examples as we go along. But since we already know all about classes and methods and static and whatnot, I'm not going to explain too much of it. I'm just going to kind of show you how we can create instances of inner classes in different ways. So what I'm going to start by doing is inside of this outer class here that I've already created, you can see on the side here, I'm just going to create another class called inner class. All right. Now, inner class is just going to simply have one method in it, and I'm just going to make this a public void display. And in here, all I'm going to do is simply just display something to the screen so we know that we're actually in the right class here, okay? And I'll say this is an inner class, okay? And what's our error here? Class at token. Interesting. Must have made a mistake somewhere here. 1 second, guys. Oh, sorry. I put these two brackets here. Don't know why I added those. Anyways, okay. So this is an inner class. Now, outside of this class, I'm going to create another method that's going to be a part of the outer class, okay? So this class is actually contained within the outer class, meaning that currently, since it's private, we can only actually access it from within our class. So if we want to create an instance of this, that means we must need a method in our class to do that. So in this case, I'm going to say public void inner, and in here, we're going to take nothing. And all we're going to do is we're going to create an instance of our inner class and just display it, okay? So we're just going to say inner class in equals new inner class, like that, okay? And then all we're going to do is just call in.display and make sure that this is working. Okay, so now our class is finished. We have an inner class and we have this void inner, and all that does is create an instance of our inner class and print it to the screen. Again, note that this is private, meaning we can only access it from within our class, okay? So now if I go to my main.java, I can run a command, or whatever, create an object so we can see this. So first of all, what I have to do is create an outer class object so that we can call that inner class. So outer class out equals new, and then outer class. Now it is worth noting that I don't have any constructors here, meaning that I don't need to give any information to my outer class or my inner class when I first call it, and that's why I can just leave these blank brackets, okay? So now if I want to see my inner class, what I have to do is I have to do out.inner, okay? So we'll call that method to create the inner class and then run that. So let's run quickly here, and we can see we get this is an inner class. Awesome, so that's working fine. Now I'm just going to make this public now, and I'm going to show you how we can do this from outside of the class. So right now what we need to do is we need to create an instance of outer class, and then we need to call the method inner to be able to create the inner class, and that's because this was private. But now that it's public, we should be able to create an instance of it outside of the class. So the way that we do that is we still need an instance of outer class because this class is defined within outer class. So we need to first create this so that this is kind of created, right? So we did that. We have outer class. Now what I can do is I can say outer class dot inner class, okay, and we'll just call this one in equals, oops, lowercase, equals out, which is going to be our instance of outer class dot, and then in this case we're going to type inner class. I believe this is correct, but I guess we'll see. Oh, I probably need an equal sign. And we'll type new out.inner class, and let's see what our little red line is. Create class inner class in package out. Interesting. 1 second, guys. Okay, so that's what the issue. I knew it was something like this. What we need to do is we need to do out.new and then inner class, because we're creating a new instance inside of this, right, of outer class of inner class. Okay, so now what we've done is we've created this in, which is an object, which is a new inner class. So now we can simply use in, which is an instance of inner class, right, to display. So now we can do in.display. Okay, so if we run this, you can see this is an inner class and that is working fine. So those are two ways we can get to access the inner class. Now, right now you might be like, okay, well, why the heck would I do this? Because now it's just like a ton more lines. Well, there's many times where you don't really care about like this instance and you just want an instance of the object inside of it. So in that case, this would make more sense to do. And obviously you would most likely have more methods than just one that you're going to be using, okay? All right, so now that we have that, I guess let's show creating this kind of inner class stuff. So I'm going to delete this inside of a method. So we can actually create these inside of methods, which are really useful because sometimes within the method, we want to use a class and we don't want to have to define like a new file for another class, okay? So we have this public void inner. So I guess let's just work with this right now. You know, we'll even leave inner class right now and I'm going to show you how this works. So all I can do in here is I can say, we can do public, you do private. In this case, I'm just going to say, I'm going to just say class. Let's see. Class, inner class. And then here, yes, that works fine. We're just going to redefine display. So we'll just say public void display. And now that I think of it, I probably could have just copied all my other code, but whatever. Get some practice typing. Print ln. And then in here again, well, this should probably be a T. We will just type inner class, okay? So this is going to work perfectly fine. Whenever we call this void inner, then we have this class inner class. We're going to create an instance of it and we're going to display it. So if I run this, I guess, wow, I really should have just kept all that code, but that's fine. Why is this not giving me the autocorrect? Outer class, out equals new, and we'll go outer class and brackets, and then in this case we'll simply just call out dot inner. Okay, so now we can see what should happen is, again, we should print inner class. So there we go, and we get inner class. Now pretty much you can do this like wherever you want. The reason I'm not saying this is public or private is just because like it's already within this void. So to use it, we're gonna have to call this void. So there's not really any point in putting like private or public. But again, like if you wanted to, you could type public class, inner class, or, oh, actually it's saying you can't do that. So I guess I was right the first time. So since it's inside of this void, you're only gonna be able to use it when we call this. So there's no point in really giving it like a public or private method or class name, sorry. Because in here, we can still do public and private methods because, well, outside of the class, we might be using those methods, right? So you can see, obviously, since I'm creating this instance inside of the void, so inside of inner, and if I tried to do that outside of it, it wouldn't work because this class is only defined when we call the inner method, okay? Now, interfaces are, I think they're unique to Java, actually, because I haven't heard of them in any other languages, but they're somewhat similar to classes. They have to do with, like, inheritance, and anyways, you guys will see as we go through the video, but they're pretty useful, and yeah, they're an important part of Java, so we need to learn them. So what we're going to do, first of all, is we're going to create a new interface. Now, just like we created a new class, we're just going to right-click on tutorial 1, our package, go to new, and instead of class, obviously, we're going to click interface. Now, I'm just going to name this one vehicle for the example that I'm going to be doing. So I'll click vehicle, and that's all you need to do. There's no, like, you don't have to do package, generate comments. That's fine. Just do vehicle. All right. Now we have an interface called vehicle. So what is an interface? Well, pretty much it is something that is completely abstract. Now, this is kind of a new concept, but it means that we're not actually going to you can't create an instance of an interface. All it's meant to do is to be inherited from. So if we have a class like car, for example, that I've created here, car could implement the interface and use it, but we're never going to create an instance of an interface. It's just here so that we can implement it into different classes. Hope that makes sense. So inside of our interfaces, and you'll see in a second, we can only have public methods, and we actually don't define anything inside the methods or the attributes. So when I create a method in an interface, and I'll just make one now, I guess, I'm going to do, let's see here, void speed up, and we'll take as a parameter int a. That's all I do when I create a method. I don't put the brackets, I don't do anything inside the method. I just create this. Now you can see that this is completely abstract because it doesn't actually do anything. It just defines the fact that this method exists. So similar to when you create a variable and you don't give it a value, that's kind of what we're doing here, because we're gonna use this in our car class. And I kind of have to go through all of it before you're really gonna understand. But when you create a method, just know that you don't give it any content. All you do is just say like this method will exist in any of the classes that implement this, okay? So I'm gonna create a few methods here and what do you call it, like a attribute, and then we'll just move into actually using the interface because that's the easiest way to understand it. So I'm gonna say we have speed up, we're gonna have slow down, and we'll have, let's go change gear as well, okay? Just doing a classic example that we're gonna implement a vehicle from a car, and you guys will see what I mean in a second, okay? Change gear. Okay, and then I'm gonna add a attribute. Now, any attributes that I add in here, like variables or whatever you guys want to call them, they have to be final. Now, I'm not sure if you remember in the last video, but final means that it's a constant and it cannot change, okay? Like we can't change this value. So I'm gonna say final int a equals, and then let's just say 5. Okay, actually, or let's just go gears, okay? Like final int gears equals 5, saying that each thing we're using is gonna have 5 gears. Now watch, if I try to just do int gears equals 5, that still works, but it's not gonna work in the way that we want, okay? So just make sure whenever you're doing this, you make them final. If you wanna have like variables or whatever that you wanna use in all of the different classes, they must be final, okay? So right now we've defined 3 methods and we have 1 attribute, which is just called gears, okay? So how do we use this interface now, and how does that work? Well, the way we use it is we type implements, and you might have seen this before, and then the name of the interface. So in this case, vehicle, okay? And you can see already that we're getting a red line, we're getting an error. So there's nothing wrong here because we can implement it, but car is saying the type car must implement the inherited abstract method, okay? So that means that since we've defined these 3 methods here inside of our interface of vehicle, we have to define them inside our car class. So whatever methods we put here, if we implement one of the interfaces, we have to define them, because right now they're completely abstract, and if we call them, well, we have no idea what to do because there's no content for them, right? So we're gonna have to create a void, which is change gears. I'm gonna say public void change. Did I call it gears or gear? Let's see, change gear. Okay, so change gear, and then it's gonna have to take 1 parameter. In this case, we're gonna say int gear. So like, what gear do we want to change to? Okay, and then we're just gonna go up here and we're just gonna say private int gear, because we're gonna define that when we change gears. All right. Okay, so now we're gonna go to and make another the other one that we need. So let's just check here. We need speed up. So we'll say public void speed up, and in here we'll have int speed as like what speed or actually not speed. We're gonna go int change. So how much we're gonna speed up by. And then we'll do one more, so public void slow down like this, and again we need this change, and there we go. So this, now we're getting no errors because we've implemented all of the methods that were abstract over here, okay? Now gears, we don't need to do anything with it, it's just like if we wanted to use it, we could, okay? So what I'm gonna do now is inside, I'm actually gonna create another private int, and I'm gonna call this speed, okay? What I'm gonna do now is I'm going to just fill up these, what do you call these methods? So I'm going to say when we change gear, we're just going to say this dot gear equals whatever gear we're changing it to. And then for speed up, I'm going to say this dot speed, actually plus equals change. Okay. And then down here, we'll say this dot speed minus equals change. Okay. And change. Perfect. Okay. So now what we're going to do is we're actually just going to add one more method just to show how this works. So we've implemented the things we need to implement from our interface. And now what we're going to do is we are going to just create another method. So in this case, I'm going to make this like a display method so that we can display our, I don't know, car pretty easily. Okay, so public void display. And inside of here, I'm just going to print out a few things to the screen. So system.out.println. And in this case, we'll just say I am a car, comma, and then we'll just add, actually let's say going, and how fast are we going? We're going this dot speed, And if we wanted to, we could add like a little kilometers per hour. So let's do that. And I am in gear, and we'll just add whatever the gear is. So this dot gear. Perfect. Okay. So let's now actually use this. So we have our interface vehicle, okay, and we have our car. So what we're going to do now is we're going to create a car object. So we'll say car, I don't know, let's say Ford, okay, equals new car. Okay, perfect. And now what we're going to do is we're just going to say car dot or Ford, I guess is what we need to do. We'll say Ford dot speed up, and let's maybe change it to 10. We'll add 10 to it. And I just realized that we're actually going to have to make this speed default at like 0, and gears, let's just do that default 0 as well. Otherwise we're going to run into an error. Or actually gear, I guess you can't really be in gear 0, can you? Let's change that to 1. Okay, perfect. Okay, so Ford.speed up, and then we'll say Ford.change gear, and let's just change to gear 2. Okay, and then if we want to display our Ford, we can do Ford.display. Perfect. Okay, so let's run this now and see if everything's working. So we say I'm a car going 10 kilometers an hour, and I am in gear 2. Perfect. So that's working fine, and we've implemented all that stuff from our vehicle interface. So now I'm going to show you some cool things we can add into our interfaces that make them a lot more useful. So say, for example, you've used a bunch of interfaces with a bunch of classes you've inherited from them, and now what you want to do is you want to add a method to all of those classes that are inherited from it. Well, what you could do is you could do the same thing here, and you could type something like this, and then you could go into every single one of your classes and you could change them to be whatever you want. But if you want the method to be the same for all of them, we can actually use something, this is why interfaces are kind of useful, called default, okay? So if we type default, and then maybe in this case void, and let's just say like out, like we're going to print something out, just make it easy. What we'll do here is we'll just, we can just create a method, and we can use this from any of the classes that inherit our interface, okay? So all I'll do here, let's say system dot out dot println. In this case, I'll just say default method. Okay. I know, very creative. How did I just spell system? Am I okay? Anyways, all right. I'm tired, guys. I apologize. System dot out dot println default method. Okay, so now that we have that, from within this car class, we can use that default method. So say when we display, we want to print that, and then we want to do the default. What we could do, I believe, is we can say just out maybe. And yes, that actually works fine. So now that we have out, because that is a method within our vehicle class and we implement it, let's see what happens when we run our program. We get I am a car going 10 kilometers an hour, and I am in gear 2, and then it says default method. And it's using that default method that we created inside of our interface. Now, I believe we can actually use static methods as well. So this would be known as something that's not a static method because we have to call it from within our class. But we can actually create static methods within our interface that we can then just call statically. Like we don't have to have an instance to call them. So if you don't know what I mean, just follow along for a second as I'm going to create a static, I don't know, let's just do like int, let's return something, let's change it up. Let's just call this math. Actually, I feel like math is a keyword. That's fine, we'll just do math, okay? We're gonna take int b, and all we're gonna do is we're just gonna return b plus 9, okay? I know, very basic, but that's all we're gonna do just to prove a point. So now, say I'm in my main.java, all right? And we get rid of this, we don't create a car object. And I want to use this static method inside of my interface. Well, what I can do is I can do vehicle dot, and then you can see it already has this function coming up, or this method, dot math, give it a value like 5. I'm just gonna actually set this equal to a variable, so we'll say int x equals that, and then we can system dot out that, and see what we're actually getting as a value. And in this case, we should be getting 14, right? Yeah, so 14, there we go. So that's how you can create a static method inside of your interface. So in some cases, you can kind of think of these as functions, all right? Say you had, and actually, you know what, I'll just do one as an example because this is kind of useful. If I go new interface and we call this math, okay? Then inside here, you could do a bunch of static methods that will do like math operations for you. Like maybe you had the quadratic formula, maybe you had, I don't know, like Euclidean distance, like I don't know, a bunch of different math formulas. You put them all in this math interface, and then when you want to access them, you would come in here and you'd say, well, math dot maybe like square root, like sqrt, okay? And then there you'd be able to use all of those, I want to call functions, but they're really methods inside the interface really easily. So that is a really good example of when you can kind of use interfaces. Now, enums are pretty much a collection of constants that we can reference, and then we can do things with those constants, and they are pretty cool and just make your code more readable. And yeah, you guys will see when we go through the video. So the first step is to create an enum. Now, to do that, it's similar to creating a class or an interface or whatever. Go to your package, right click, you're gonna click new, and then enum. So for enum, I'm just gonna name mine, actually, I'm just gonna name mine level, because you'll see why it just makes sense for this example. So again, the syntax here is public enum level rather than like class or interface or whatever, right? So in here is where we're going to define our constants, okay? Now this is really useful because we don't have to do like public static int whatever, like the name. Like we can literally just type whatever value we want our constant to be, and typically it's a string. So in my case, I'm going to go for level, I'm going to go in all caps. You don't have to go in all caps. I'm going to go high, medium, and low. Okay, now these are the three constants I'm going to store in my level enum. So we have high, medium, low, and yeah, that's literally all I'm going to do right now for my enum. It just means we have three constants that we can reference from level, and these are the three. And obviously you could do as many as you want and just keep going with commas on, and I think you can put them on the same line as well. It just makes it more readable if you do them like other lines. Okay, so there we go, three constants. Now I'm going to show you how we can actually use this enum, and you'll start to understand how it works. So to use this enum, we have to create a new instance of it. So to do this, I'm going to say level, and we'll just say LVL equals new, or actually, I think it's like this, equals level dot, and then yeah, so we say high, low, and medium. So in my case, we'll just pick low, and I'll put a semicolon. And now you can see it's all showing up in different colors, and this is working fine. So now that we have this as a constant, we can do certain things with it, right? So typically you might want to check what value your constant is. So like what value is level. So we can obviously use these in an if statement like so. So if I say like if LVL equals, and then I think it's level dot, and then we'll start at low, I guess. And we'll just work our way up to high. And we can say elif or else if, and we'll say LVL equals, and then level dot and medium. Okay, we'll do something in there, and then finally else, because if it's not low or medium, it must be high. Then we'll just do something here. So in this case, we'll just say system.out.println, and we're just going to print level for all of them just because I want to show what this does. Okay. Oh, what the heck did I just do there? Okay. Anyways. Okay, so now we're just printing level each time, and actually let's just run this now and see what happens. So you see we get low. So when we print out level, it's simply just going to print like whatever the constant is that we have. And that's because it has like a little toString method built in, so we can convert these into a string. And I'll show you what I mean by that. So pretty much say we wanted to get this, because right now, like, it's not a string, it's not an int, it's not a Boolean. We don't really know what type it is. It's just like in level, like it's an enum. So to actually get this as a string value, if we wanted to do something with it or store it, we can use .toString. So if I say string, we'll say en, why not? We'll say is equal to lvl.toString. And that's just going to convert this to a string for us, and then we can do all our string operations or whatnot with that, all right? So that's how you get it to a string. Now another really useful thing with enums is we can actually get all the different values of enums and print that to the screen. So I do system.out.println, and I believe the way we do this is we go level.values. Yes, there we are. So we go level.values, and if we hit that, or we type that in, you're going to see when we run this now, it gives us, well, it's actually giving us an array with the values. So when we try to print that, we're getting like, you know, the memory address of it. So once we have these values, I'm actually just going to store this in an array so that we can then iterate through it and print them out. What I'm going to do is I'll say level array, and this is the way you have to do it. We'll say arr is equal to, and then level.values. Okay, so that's working fine. So what we're going to do now is we'll just create a quick for loop. So, and I'll show you how we can loop through all the different values. So say for e, or what should it be? S level e, and then we'll say in ARR. What we'll do is we'll simply just print out e, okay? So system.print out e, and then we can see all the different constants that we're going to get. So let's go here, and you see we get high, medium, low, and then it just prints low again just because we're doing this little if statement here, okay? And that's how you can loop through all the different values. So that's really cool, but you might say, okay, well, that's cool, Tim, but is this really that useful? Like, we just have these constants. Well, there's a few other things that we can do inside of this enum. We can add some methods and some constructors as well, so that these constants actually point to certain values, kind of similar to like a hash table or a hash map that I showed you before. So the way that we can do that is we need to create, first of all, a variable that's going to be private. So in this case, I'm going to say private, and I'll say actually int level LVL num, okay? So this is going to just be a private value that's just going to store the value of each of these, so like low, medium, high, the value of all these levels. So to set this value, what we need to do is we need to create a constructor for our enum, and you'll see how this works in a second. So I'm just going to say public level int and then num, okay? And in here, actually, what are we getting here? Remove invalid modifiers. Legal modifier for enum constructor, only private is permitted. Okay, so let's just do this. Private, sorry, my bad. Private, because we're just going to call it on here. You'll see in a second. Private level int num, and then we're just going to say this dot LVL num is equal to num. Okay, there we go. So now what I can actually do is, you see how these are highlighting in red? So since this is a private constructor, that means we're going to define this variable based on what constant we choose for the enum. So I'm going to put brackets here, and I'm going to define high as 3, medium as 2, and low as 1. Now what this is going to do is it's going to keep our same constants of high, medium, and low, but when we create a new constant, it's going to activate this constructor of level, and it's going to set this level num equal to whatever value we put in the brackets here. So in this case, 3, 2, 1. We could obviously have multiple, parameters here, and then we could have multiple arguments here, and we can have a ton of different values. And yeah, so the only issue is, since this value is private, we're going to need a way to access it from our main here, because that's probably where we're going to want to use it. So that means we're going to have to create a few methods to, well, change that level num and to get that level num. So we've done this before, but actually I don't think I can do a public, we'll see if we can, public get level, and then in here we'll simply return, I guess this is going to need to be an int, public int get level. We'll simply return this dot LVL num. Okay, yeah, so that does work fine. I just can't do a public constructor. Okay, so this is just going to give us the level num if we call get level on our enum. Okay, now to change this, level num, what I'm going to do is I'm going to do set LVL, and instead of having int here, it's just going to be a void. Okay, and all we're going to say is this dot LVL num is equal to num, and then we're going to put in here int num. Okay, perfect. So now what we're doing is we have a way to not only get the level num, but to change it. So now let's try using this out in our main and see how this works. So I'm just going to get rid of all this stuff because we don't need this for right now. So right now we have our level, and it's level.low. So to actually get the value of this level, we can use something called get value of, or we can use that method that we had here. So in this case, I'm going to say get level. So what I'll do is I'll say system dot out dot println, and in here we'll say LVL dot, and then what was the thing we were using? Get level, like this. So now if we print this out to the screen, we should be getting 1, and indeed we are. We're getting 1. So now I want to show you this thing. It's called get value of. Okay, and it's value of or get value of? I'm not sure. We'll see. So I'm pretty sure if we do something like this, level dot value of, yes, that is exactly what it is. And then we pick, we type in whatever the enum is. So in this case, we could say low. It's going to give us, let's see, what's the issue here? Okay, yeah, so the issue is I just got to put this in string. I just forgot about that. So if I do level.getValue of, and say I put a string in here. So like say someone was typing in and into the computer, and they type in a string, right, and you want to pass this into get value of, we see what we're actually going to get is we get low, right? Because that is the value of this string in the enum. Although it's not a string, it can like determine that, okay? So that's what value of is used for. I can't really give you any good examples of them because I don't really know any good examples of using value of, but for any of you that might see some use in it, I figured I would show it to you. So I guess we can do an example now of just setting the level just to make sure that all of that is working. Say lvl.setLevel, and in this case, let's say 5, and then let's just grab this again, actually, and we can delete this from up here. And now I'm just simply going to print out what do you call it, lvl.getLevel, and just make sure that everything is changing and working fine. And there we go, we get a level of 5. So that is how we can use enums. Pretty much they're used for when you want to have a collection of different constants. Maybe you want to loop through, see what those constants are, and it just makes our code kind of readable, right? Because we have level.low, and then that low can point to like 5, 2, 1, whatever, and that's all stored within our enum right here. Obviously, you can have as many enums as you want, and you'll really see the use of them further on in Java when you're creating like larger programs, okay? So anyways, that has been it for this video. If you guys enjoyed, please make sure you leave a like and subscribe, and I will see you again in another video.